Good morning, ladies and gentlemen. On behalf of Indian Chamber of Commerce, I would like to welcome you all to the fifth edition of the Cementing India Conference today. We are expecting the Honorable Minister Dr. Shashi Panja by 11. In the meanwhile, we'll start the program. So I'll therefore request all the speakers to kindly join us in the dais. I would request Dr. Rajiv Singh, Director General of Indian Chamber of Commerce, to kindly join us. Mr. Vedant Agarwal, Director of Purbanchal Cement, Mr. Anil Banchor, Managing Director and CEO of RDC Concrete, Mr. Nilotpal Kaur, Managing Director of MBCC India, and Mr. Madhusudan Rasiraju, Country Head of IKN Engineering India Private Limited, to kindly join us. I would request Dr. Rajiv Singh, Director General of Indian Chamber of Commerce, to kindly deliver the welcome address.
So good morning all. Welcome to all of you, especially during a month when Calcutta weather is at its best, and it is going to become better going ahead over next 2 months. So I think it's a great time to meet and also to discuss business. We are extremely happy and honored that we have industry leaders who represent the cement as a sector, and I have pleasure in extending a warm welcome to start with Mr. Vedant Agarwal, Director Purbanchal Cement Limited. Again, a warm welcome to Mr. Anil Banchor, Managing Director and CEO, RDC Concrete India Private Limited. Equally warm welcome to Mr. Nilotpal Kaur, Managing Director of MBCC India. A warm welcome again to Mr. Madhusudan Rasiraju, Country Head of IKN Engineering India Private Limited. As you have heard, Honorable Minister will be joining us shortly, but respecting the time and in the interest of time, we thought we should start. And just a thought, maybe when Minister is with us, maybe each one of us can make a brief 1 or 2 minutes comment, just to give her the context. And also if we have some ideas for Bengal, or if there are any specific areas where the Minister and the Bengal government could intervene. Because Minister is quite business-like, she understands, and she's also willing to help. So it will be good to maybe have, when she's with us, 1 or 2 quick comments, suggestions for Bengal, and any specific areas where we need Bengal to intervene, we can do that. Now, I need not give any kind of technical discourse to the people who practice, who know the sector more than anybody else. But broadly, as a chamber, I would say these are the best times, because the way geopolitics has changed over the last 2 years after COVID and during COVID, considering how the global balance is shifting, most of the large companies are looking at China plus one strategy. They are looking at alternate markets, and that's how you see a lot of FDIs flowing to India and also to ASEAN, Vietnam, Indonesia. There are countries which are attracting the FDIs. Incidentally, India has been the largest FDI market over last 1 year. It has even left China behind. So these are good times. On other hand, you have government which had a very well-balanced, calibrated approach to deal with the COVID, and that is now paying off. Inflation numbers are not very high. Government has huge plans to invest in and connectivity. If you look at connecting the east-west east-west corridors, logistics parks. Government has a very ambitious Gati Shakti plan, which basically brings every connectivity segment on same platform, and government has a clear view of what's moving, what are the synergies, and how various ministries can also collaborate. Because earlier one ministry used to develop, let's say, railways, but the highways and the ports, they were missing links. And once the project was done, then governments or the states or the companies used to struggle. So that's happening, and government has huge investment plans. Fortunately, the markets are also now looking up, although people feel that next year again recession could hit us. But still, India, I mean, compared to many economies, would still continue to do well. Fortunately, the real estate sector demand is also picking up. So I think the demand exists. There's no doubt on that. And as you all know, India also has the high quantity and quality of limestone deposits throughout the country. So the cement industry in India has huge promise. The sector has seen tremendous growth since 1982 and after delicensing in 1991. There are estimates that the demand is going to grow at the rate of 10%. So accordingly, the capacities or the volumes will also grow, and it will reach a sizable scale on the global cement industry map. Now, especially the eastern states of India will be the newer markets, and they are already showing promising growth for the cement companies, and they could also contribute to the bottom line going ahead in a bigger way. India has potential to also become the main exporter of the clinker and the grey cement to the West Asia, Africa, and other developing nations of the world. Cement plants mostly you have seen coming up near to the ports, and Bengal is also now looking at developing a deep sea port. Adani port is working on it, and they'll be developing the port. So that could also be another advantage for Bengal, and Bengal being the feeder market for entire eastern region. So Bengal definitely has a case, and since we are based here, so it's my job also to pitch the Bengal potential. Again, the future looks very bright for the domestic companies. They could go for global listings either through FCCB routes or other routes. And but today's focus, if you have seen globally, even at various forums, whether that is G20 or any other forum, or even a COP meeting, you have seen green being the focus. Reducing carbon emissions has been one of the major focus of governments worldwide. And India has already made significant commitments. If you see the solar capacity addition, I think India has crossed the targets which were assigned, which India had accepted. And now this is going to spread to all sectors, and especially sectors which contribute to the carbon emissions. So that is also one of the focus today, and I'm sure we will hear from the experts how we could decarbonize. It will not be a complete decarbonize process, but how do we start the journey? And I'm sure some of the companies have already started on a small way, and this is going to grow because even in the global markets and the national markets, there would be incentives or restrictions for the compliance, and it makes business sense going ahead to look at the green tech, and but it's not easy. It's challenging because it means huge costs, and also technologies which are available, and the viability of those. So considering that, I think it will be important to discuss, find ways, and look at what makes sense, what is viable, how do we start the process and spread it on a larger scale. The technologies what we have as of now, but they include like how do you make the entire manufacturing process energy efficient. Also switching to low carbon fuels is one option. Reducing the clinker to cement ratio and implementing carbon capture, and basically these are known as CCU technologies. There are various studies which basically depict that if you switch the fuel, it could have an impact. But we have the experts here who will talk more on how cement industry looks at it and how going ahead industry plans to keep pace with not only the national ambitions but also the global compulsions which are going to come, and these are going to grow stronger going ahead. At the end, I would say that this sector is important for East, and this sector is rather important for the country and the kind of ambitions India has to grow. Especially in East, you see a lot of activity and growth in terms of construction in the border areas, whether that is the borders of China, especially China. A lot of ports, railways, highways, a lot of activities happening, and in the real estate space also you see a lot of investments and a lot of demand. Similarly, all these FDIs which are happening, they also mean activity, investments. So the future looks bright, and may I once again extend a warm welcome to all of you and all the participants and the guests here, and I'm sure we'll have a very fruitful day. Thank you.
Thank you so much, sir, for such an informative start. And now I will request our next speaker, Mr. Vedant Agarwal from Purvanchal Cement, to kindly address the gathering.
Thank you, Mr. Rajiv. That was very informative. And I do have a few things to add to your points. Good morning, ladies and gentlemen. I'm privileged and honored to welcome you to the 5th edition of Cementing India. Special thanks to Dr. Shashi Panjaji, since she's not made it here, but for taking the time out of her busy schedule to be here. It's my sheer pleasure and honor to be here on this dais that essentially opens up a window for me to interact, understand, and learn on cement industry from the distinguished individuals sitting in front of me. My name is Vedant Agarwal, and I'm a mechanical engineer from Purdue University. I was asked to speak a few words on decarbonization of cement. However, I don't think I can do justice on this subject, how much ever I try in front of leaders like you all, who have experiences greater than my current age. I'm 24. To my understanding, cement as a commodity has a bright future. Through the industry has poised to go through exponential changes, be it process or the product. I'm sure there will be constant innovation. There will be focus on green cement concept, etc., like Sir mentioned, along with some new products to meet the ever-changing needs and aspirations of customers globally. Let's not forget the G20 summit in 2023 India. So speaking a little bit about decarbonization, so currently at our plant, which is in Sonapur near Assam, we are exploring solar OPEX modules, where we have a lease period with companies from abroad, and grinding additives like Enerpac, designed by one of our fraternity members, has been doing great. So we've been exploring some of those opportunities. But however, there are a few concerns in the industry, like coal shortages. That's been a major concern, and rising raw material prices that have pushed our costs so high but I hope with intervention from leaders like Dr. Shashi Panjaji, we'll help and find a solution. Since I've been allotted a limited time, I would, since you know a little bit about me, I would like you to show you a presentation about my company and what we do. That's my heart and soul, Surya Cement. So, Purvanchal Cement is a family-owned company, and it's a part of Maithan Group, started by my late grandfather, Basant Kumar Agarwala. And besides cement, we entered cement in 2008. Before that, we were mainly into mining ferroalloys and refractories, Maithan Ceramic, Maithan Alloys, Anjani Ferroalloys, Maithan Steel and Power. I know this is not visible, but my goal is to have my carbon emission to grow my capacity with the market size and adding green decarbonizing methods year on year. I'm sure everyone understands this. So we have the first company in the eastern region to introduce a premium brand called the Surya Concretech. We have the regular PPC and the OPC. Some of our standard and quality control. We try and adhere to the maximum safety and quality assurance at our plants. This speaks a little bit about our Concretech product. So basically with the Concretech, what we've tried to do is we've changed the ratio and we've worked on how to get a better result, basically increasing the clinker, the ratio of clinker to cement in the Concretech, and it has a very good response in the northeastern market. All our competitors have followed suit and it's been paying well, but Concretech is one product that has captured the market, especially the Assam market. This is some of our rural marketing team. We work with majorly all clients. We are present almost in every company in Assam. Basically, I think I want to be a leader, and I think with the cement fraternity present here, thank you for giving me this opportunity. I am excited to embark on this journey and grow together as a team. This industry is fairly new to me, and I think I would need all your help and support, and soon, we can create something bigger and greater for all of us. Thank you so much, sir.
Thank you so much, Mr. Agarwal. We wish you all the best in your future endeavors. And now I would request our next speaker, Mr. Anil Banchor from RDC Concrete, to kindly address the gathering.
Good morning, ladies and gentlemen. As Mr. Rajiv Singh has said about, the lot of opportunities in the coming years because of the government focus on the infrastructure. A lot of developments are coming, and the cement demand is going to go up in coming days, and next 10 years will be like a golden time for cement and infrastructure companies. So cement has got basically two use as an end use. One is a mortar, which is used as a brickwork or plaster, and second part is a concrete. This is the end use of cement, right? When we talk about the decarbonization in cement industry, the decarbonizing in this concrete industry is also very, very important. And not only for the carbon reduction point of view, but also for the sustainability. Because in the coming days, the concrete demand will go up, cement demand will go up, and our reserves are limited. How we are going to preserve our limited resources for a longer time for future generation, that is also very, very important. The two aspects. One is a reduction in the carbon footprint. Second is preserving the resources. So my focus on the presentation is on the concrete side, where around 50% of cement is going to the concrete, and the demand of concrete is going to grow up in coming days. I'll just cover how to reduce the cement consumption. People say if you want to reduce the carbon, right, to reduce the cement consumption or reduce the cement production, the carbon emission will be less, because 1 ton of cement production leads to around 1 ton of carbon dioxide emission. So looking at our growth, we cannot eliminate the cement production. But how can we preserve this cement or reserves for a longer time? Better is to reduce the cement consumption per kilometer of concrete. If you are using say 400 kg per kilometer of concrete, then reduce it to 300 kg per kilometer of concrete or 200 kg per kilometer of concrete for the same performance. Performance is similar to what we are using now with the higher cement content. Then other operational improvements, inbound logistics, outbound logistics, that is also leading to a lot of carbon emission. So demand for cement and concrete is going to go up, right? And cement industry is growing at 5.5% CAGR. Concrete industry is also growing at around 15% CAGR. Maybe in coming years, this percentage will increase, right? And this, out of the total, carbon emission by humanity is around 7% by the cement production. This is very high. The installed capacity wise, these are the numbers which are published, so 502 million ton and production is around 328, though the production is less than the capacity, but it is going to grow up. Okay, the limestone resources are also depleting with the growing demand, so we have to preserve that. This I have tried to explain through an example. If you see here, the pure OPC mix, in the table if you see M30 grade of concrete, which is the common grade of concrete which is made in India, right, M25 and 30. This is the example M30. So if you use pure OPC cement, around 370 kg of cement is required. There is a chart here, you can see both sides, the first column, 370 kg. So 370 kg of cement will lead to around 370 kg emission, carbon dioxide emission. If you use around 25% fly ash with OPC, then this quantity will come down to 322 kg of OPC and 108 kg of fly ash. And effectively, the carbon emission will come down to 322 from 370. If you use OPC plus GGBS, which you can use at a 50%, then this emission will come down to further to 200 kg, from 370 to 200. If you use PPC, because cement industry is producing a lot of PPC, right, it is a good product, the carbon emission will come down to 340 kg as compared to 400, right? So this is a possible reduction. But the issue is GGBS is not there in everywhere, in all places in India. It is there in certain pockets, it is there in the western pocket, southern pocket and eastern pockets. But the usage we have to improve. This is what is very, very important.
Please come.
Welcome to Madam Sashi Pandaji. So I was speaking about how to reduce the carbon emission per cubic meter of concrete of say M30 grade. So you can see here comparatively how can we reduce the carbon footprint, right? And this possible reduction in carbon emission can go up to 13 to 46% with the use of fly ash or with the use of GGBS. But these ability of these two material is not there in everywhere in India. But wherever possible, we should use it. The possible reduction is around 50 to 170 kg per kilometer of concrete emission is possible. Reduction is possible. Now you see here in this table, the total cement production of FY22 is around 328 million ton. Cement consumed in the form of mortar, which is 50%, right, which is around 164 million ton, and 50% of cement is going for production of concrete. And this production of concrete, it happens in the site-based mixers with the rural area or smaller towns where the drum mixers are there, but 50% of cement of that is going to ready-mix concrete with a batching plant. These batching plants are with the contractor or construction companies and infrastructure sites, or many, construction sites of the government projects or the commercial ready-mix concrete plant. And this cement consumption is around 82 million ton of cement which is used for the concrete. And if you say 300 kg cement is used per cubic meter of concrete, then it comes to around 273 million cubic meter of concrete. And by using this, with the earlier example of the use of fly ash and GGBS, you can reduce around 0.11 ton per cubic meter of concrete. And total reduction in carbon emission which is possible is 30 million ton. This is very, very big contribution if you can use more of fly ash, more of GGBS to all possible locations. Right? Only challenge is to transport these fly ash and GGBS from the generating locations to the consumption center. Right? This is the logistics is one issue if we can make it possible. So this is the biggest number which we can reduce. Then, and the site mix here, the last point, in the site mix where the batching plants are not there, people should not be using OPC. They should use PPC or PSC. At least they will be helping in reduction in the carbon footprint. And all government departments, they should make it mandatory. No OPC should be used in the site mix. There is further opportunity for ultrafine minerals, which is materials, which is high performing materials. If you use these materials in the concrete, then you can drastically reduce the cement consumption per cubic meter concrete. In this example, again, M30 grade concrete is there. And the OPC is 322 kg, fly ash is 108 kg. And if you see the right side of the table, where 322 kg cement, you can reduce to 248 kg for the same performance. Same performance of slump, flow, and the performance of durability, performance of strength. So you can add this mineral additives up to 10% of the concrete, and 1 kg of this ultrafine material is going to replace around 3.5 kg of cement. You can imagine. 3.5 times you can reduce. But there is limitation. So only you can use up to 10% of the cementitious material. But here also, if you can use, say, at least in 50% of the total concrete produced, at least 20 million ton of carbon dioxide can be reduced. This is a big opportunity to use these ultrafine materials. Now coming to inbound and outbound logistics, because CNG is available in certain cities, like it is there in Maharashtra, it is there in Gujarat, there in Delhi, and diesel trucks are emitting around per kilometer run, it is emitting around 1.35 kg of carbon dioxide. If you use CNG, it is not totally eliminated, but is reduced. It is 1.1. The differential is 0.25 kg reduction per kilometer of running. If the truck runs for 3,000 kilometers in a month, in a city, the concrete trucks, I'm talking the ready mix industry, the concrete trucks. So each truck will emit around 750 kg less carbon dioxide in the atmosphere. Right? They can use a clean fuel. This is also very, very important. And if I convert into terms of cubic meter, is 1.25 kg per cubic meter, which is around 18.5%. There is also possible reduction is 0.1 million ton reduction of carbon dioxide by using this CNG. I have not taken the figure for the all India, but it is only for 25% of the concrete delivered. Then outbound, the diesel trucks, right? Diesel trucks is emitting around 1.35 kg per kilometer. Biodiesel is another, we can produce the biodiesel more and more in different states and start using this biodiesel. And here also reduction possible is around 1 kg per kilometer run. This is also very, very important. If I convert this into kg per cubic meter, then it is coming around 5 kg per cubic meter reduction. The biodiesel is one which is in our hand. It is not like CNG, which is not available in every state. But biodiesel is one which can be used in every state. Right? The production of these material which can generate biodiesel is very, very important. So here the possible reduction is 0.7 million ton per annum in the concrete industry. This is very important and we can use this. Then outbound logistics, higher capacity trucks, generally people using around 6 to 7 kilometer truck capacity. And cement industry also, they started using the bigger trucks, the bigger size of trucks leading to less carbon footprint in the industry, and like concrete industry also should be using around 10 to 12 kilometer trucks instead of conventional 6 kilometer trucks. The possible reduction per kilometer is around 1.7 kg of carbon dioxide, which is leading to around 0.5 million ton capacity. Right, this is a simple opportunity. We should go for bigger size of trucks so that we can reduce this carbon footprint. Then few one company called InfraPime, they have started the electrically operated battery operated trucks. The battery operated scooter and car we have seen, but these battery operated trucks are also there. The few trucks have been brought as a pilot project. It is running Jaipur Delhi side, and you can see here in this, so instead of 1.35 kg emission per kilometer, it is only 0.55, right? So because this power has to come, battery has to be charged with the electrical power, and electrical power will come out of the coal. That is why it is 0.55, right? The possible reduction is around 4 kg per kilometer concrete, right? Because this RMC trucks are working, within a certain limits, within the city limits. So every day, night time it can be charged and daytime it can be used. The possible reduction is around 1.1 million ton of, carbon dioxide emission. But this battery operated trucks are very limited numbers. It is still in the pilot project, but opportunity is there to explore further. In the operation side, if you can control the power consumption in every manufacturing aspect and reduce the power, whatever power consumption is there in any industry, if you can reduce the power consumption and reduce the wastages, then we can reduce the carbon footprint. This is our industry. From 2.4 units per kilometer of consumption, we could reduce to 2.2, and our next target is 2 units per kilometer of concrete. So this small reduction will help in a big way. Then this is one scheme which we started in our industry, the e-scooters, which is very, very common. So we started giving this e-scooter to our staff going to the field, and we say within 2 years time we'll be giving free of cost, and after 2 years time it will be transferred to their name. Why? Because this will help in reducing our petroleum consumption, number one, and also reducing the carbon footprint. Okay, so these two things are very, very important. So we have initiated this process in many locations, and a lot of industry people are here. You can explore this. Okay, and 0.04 million ton of emission reduction is possible, and plus it will help the employees. And similarly for the manager and above who are entitled for the car electrically operated cars are also there. The battery operated cars. Here also we said after 4 years will be given to you free of cost. No charge to the employee, but they will be encouraged to use this, battery operated cars. This will help in the environment, right? Because these people, if they are moving within the city only, right? Why they use conventional, combustion engine cars, right? Leading to the diesel emission, diesel consumption, petrol consumption, leading to the carbon emission. This is also 0.1 million ton. So I request every industry, player to try this as a pilot. Okay, we started this and very encouraging results we are getting. Right, electrical tippers is one with a battery operated tippers, which I gave the example earlier. So similar trucks can be used in the aggregate industry also. So this is a summarized form. Yes, this is the last year. This is a summarized possible reduction, right, which is 62.8 million ton under different categories. But every category has got an opportunity to start working there. Challenges: the fly ash and GGBS supply is very limited in certain regions, but West Bengal is having a lot of GGBS because in the eastern side. So if these GGBS can be made available to construction sector in Calcutta or in the Assam side or whatever, export side, this is very good opportunity because the railways can help and the West Bengal government can, think about making a terminal in Calcutta city. There's one which is very, very important, and the acceptance of end user, like including the government bodies, when they say, include all these fly ash and GBS used in the construction industry. Biodiesel is another opportunities, right? And the truck transit mixers. So a lot of opportunities are there. So every state can do something, right? And particularly West Bengal, here in Calcutta, opportunities are huge. We can use whatever possible ways are there, particularly in the flash and GGBS side. Thank you very much. Thank you very much for your time.
Thank you, Mr. Banchor. Now we would like to welcome Dr. Shoshi Paja, Honorable Minister in charge for the Department of Industry, Commerce and Enterprise, Women and Child Development and Social Welfare, Government of West Bengal, to this initiative. It's really an honor and privilege for us, Madam, to have you here this morning. May I request you to kindly proceed for the lamp lighting.
I can recite a mantra, feed it to you. Hari Om. Agnimire Purohitam Yankesya.
वक्रतुण्ड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा ॐ गं गणपतये नमः ॐ गं गण
Thank you so much. And now I will request our next speaker, Mr. Nilotpal Kaur from MBCC India, to kindly address.
Good morning, ma'am. Good morning, Mr. Rajiv Singh, and all co-speakers out here and the August gathering out here. I'll start with a small story, and it's about Bengal. Yeah, and we need to be, and I am a proud son of Bengal, though I have moved out long time back. But every time you come back, there is also something which is very exciting. Did we know that CESC, the Calcutta Electric Supply Corporation, has filed a unique patent? If anyone there in the audience, you can raise your hand. Yes, and that is about using bottom ash in PQC or road concrete. Now that is an excellent way to start a low carbon economy, where you basically all these bottom ash. So you know that when you burn fuel or carbon or coal, you basically get fly ash, which is used in cement. So 35% in the cement manufacturing possible. And then you have bottom ash, which is used as waste, or it's basically a waste product. And if you can use that, that's a tremendous achievement, not only in concrete, but also to utilize it as a part replacement of sand. Yeah, when we are talking about manufactured sand, which also requires energy. So that is a great achievement, and I think we need to applaud this patent. So we know about sustainability, and we talk in different languages, urbanization, climate change, but the end point is durability. Yeah, the concrete structure, and we limit myself at least to speaking about concrete, which is the second most consumed material after water. Yeah, so therefore anything which talks about less repair is sustainable, low carbon economy, because you utilize a lot of repair products which require energy to be produced. It requires cement, it requires sand, etc. We talk about resource efficiency. We talk about life cycle management. We talk about eco-efficiency analysis, where all the various factors, how many liters of water you save, how much is the carbon emission reduced to, it's all about, people profit. When we talk about, the C balance, which is societal, which is economic, as well as environmental. And this is very important, and it percolates through the entire value chain of the construction industry, namely the client, the government agencies, the consultants, the ready-mix concrete suppliers, the cement manufacturers, the construction chemical manufacturers, etc. When we talk about carbon footprint, and again limiting ourselves to concrete, as Mr. Banchor has already stole the light by actually mentioning all the aspects which are possible. And we talk about 80% of the concrete which is not only used globally but also in India, which is the 20 to 25 or 30 MPa concrete. And we were talking about a reduction of 105 kg of carbon dioxide on an average per cubic meter, and you talk about 273 million cubic meter, that's a huge amount, yeah. We saw the figure of 60 million ton capability of reduction of carbon emission, and that's a great achievement. I'll give you also another story. Bangalore Development Authority rehabilitates slum, and this project was actually 3 months behind schedule, and they used a unique technology where they did not use vibration in concrete, and they used about 50% of slag, and they basically delivered the project 3 months in advance. Now, if this is possible in a slum rehabilitation, we talk about the high rises and we talk about the luxury apartments, it's all possible. The basic idea I think we all need to get clear in our mind is that if concrete is durable, residential, commercial, high rises, infrastructure, all are going to last longer. That means it's going to be more durable, with the impact that it could actually service a 50-year life cycle. When we talk about cradle to grate, yeah, and cement and concrete and aggregate, yeah, use of manufactured sand has been rampant now. And mining is actually rampant. There is less quality control, with the result that it impacts concrete, and therefore you have to rehabilitate, repair, and this is very, very common. There is also another aspect that we talk about PFA, fly ash or slag. There is always this limiting aspect because we come through this copy-paste, cut-copy-paste of specifications, especially things like railways, infrastructure, where slag or fly ash is actually left out of the code, left out of the specifications for a long period of time. Without naming the project, we are involved in a big project. Yeah, it's on the western side of India, and you would be amazed to see the specifications still recommending ordinary Portland cement, where there is a capability to use fly ash and slag to actually reduce the carbon emissions to a great extent. So everybody is interested in selling product, yeah, for the betterment of the business, for the betterment of the economy. And we are talking about lower carbon footprint, obviously with the use of supplementary cementitious material, fewer valuable resources, durability, potential impact on health and safety. When we use less energy in actually placement of concrete, like self-consolidating concrete, that means concrete which does not require vibration at all and can be pumped at a lower pump operating pressure, therefore reduction of fuel consumption, you basically actually are making it very ergonomic. And this is also a very important aspect in safety of the entire concreting or construction process. There are many projects which use recycled aggregates. Now, ready-mix concrete, most of the plants, they have returned concrete which is not used at the end of the day because the site does not require it. Now, there is a technology, admixture technology, which can actually separate the cement from the aggregate and make this aggregate again good for use for construction without impairing any of the properties of concrete. Yeah. This has already been tested in practical sense in India in many sites, and this is one of the best things which I think could also increase in sustainability. If you look at this entire pie, yeah, and I know it's a little bit difficult to read, 75% of embodied carbon of construction material is actually within commercial, residential, and residential rehabilitation. And that is the focus, I think, in India, especially being, in an accelerated steep economic growth, that there is a huge potential with so many brains around, in the country to actually go for lower embodied carbon. Geopolymer concrete, of course, in a very nascent stage, is there, already evolving. 3D printing is also another aspect. These are all which require longer discussions, but at this point in time, we're just talking about specifying low carbon concrete mixes. There are a lot of opportunities of reducing embodied carbon in concrete. And you can see the difference on the left and the right, where carbon emission, the biggest contributor is cement, and we talk about green sense concrete. This was a technology which came in from the US and has been used in many parts, even in growing economies like India, where we basically compare a reference mix with the reduction of the cement content, the pure OPC, to give a better impact in terms of reduction of water consumption, in terms of reduction of the CO2 emissions, and what can it translate into an equivalent fuel. It can be used in signature buildings, office buildings, residential buildings, and academic buildings. And this has already, it's vetted by third party. When I was in Singapore, we did it in comparison with normal concrete versus what can be actually attained through eco-efficiency analysis. And I give you just one example as we sign off. If you see, this is the 432 Park Avenue, which is a 105-story building. So you can understand 425 meters, the amount of energy required in the concrete to pump, place, etc. And if you look at the table at the bottom, the energy usage saving in terms of no vibration concrete, in terms of climate change, what is the reduction in the CO2 emission, because that only used 12% by weight of cement as cementitious content. The water emission, because you can reduce water usage in concrete. And then of course the solid waste, which is basically being used. So based on 68,800 cubic meter of concrete, the equivalent savings of CO2 emissions is almost like 4.08 million liters of fuel, and driving a passenger car for 36.6 million kilometers. So you can imagine how much this impacts and how it can impact our economy. And as I said, starting with Bengal, patented product, commercialized, I think we can lead the way here. Thank you very much for your kind attention.
Thank you so much, Mr. Kaur. And now I would request our next speaker, Mr. Madhusudhan Rasiraju from IKN Engineering India Private Limited, to kindly address.
How many of you know that IKN clinker cooler can contribute huge carbon savings while cooling the clinker? Thank you. How many of you are thinking right now how cooler can save carbon savings? Thank you. My name is Madhusudhan Rasiraju, country head of IKN Engineering India Private Limited, and we help the cement industry to reduce the clinker production cost by reducing the energy and by reducing the maintenance of the equipment. So almost about 56 companies, cement plants, reputed cement producers have invested in IKN technology, and thereby they are reduced the power consumption by 23.5 megawatt of power and 10,500 wagons of coal per year. So I thank ICC, not International Cricket Club, but Indian Chambers of Commerce for organizing this event. And also I thank Honorable Minister Dr. Shashi Panja and the delegates on the dais and the participants for sparing your time and out of your busy schedule to invest here. by the see, actually, by the end of this program, you will be aware of how vital is clinker cooling in saving energy and carbon credits savings. So, can I? Yeah. So the reduction in power consumption and reduction of cooler heat losses and the reduction in the consumption of metallic parts, that is spare parts, and increase in waste heat power generation from the cooler, and sustaining the energy levels for long periods of time are the factors that reduce the carbon emission. Let's see how IKN cooler are different from the rest. So the current existing conditions in the industry is electrical consumption for the clinker cooling is between 4.5 to 7 kilowatt per ton, and cooler losses is about 100 to 120 kilocalories per kg. Recuperation and 24 hours of running water pumps for cool the vent gases, and more power, of course, they get 0.7 megawatt in the WHRS because the cooler is inefficient, so therefore the waste heat is converted into power. And in case of IKN, we have benchmarks of 3 kilowatt per ton to 4.2 highest and 85 to 95 kilocalories per kg recuperation cooler heat losses, and 4 to 5 hours of water usage per day, and then up to 0.5 megawatt for 1.5 million tons plant. We are achieving these results and sustaining these parameters for a long period of time because of constant technological innovations. So you can see here the kits. Okay. The first one, left-hand side, you are seeing the kits, meaning clinker inlet distribution system. So this kits is made of tiny particles, tiny nozzles, which uses the Konda effect. The Konda effect, can you run this slide? This one. Yeah. So this Konda effect, when you introduce airflow through the Konda nozzle, through the curved inclined slot, the air will not flow tangential, but it follows parallel to the grate surface. Unfortunately here, this animation is not working, but you can imagine that the top layer is showing aluminum foil. When the air comes from the bottom, actually it's supposed to lift up like this. But because of the Konda effect, it goes parallel to the grate surface so that the air will not go up. So this creates a segregation of clinker. This is the kits, which is hybrid aeration, dynamic transport segments, and a variable slope, and based on the proven concept. It's called kits inlet. And this creates a segregation of the clinker that is fines on top and coarse at the bottom of the bed, and converts and makes this stratified layers of clinkers on the clinker bed. And because of the stratified layers and segregation, the heat is transferred more effectively from the hot clinker to the cold air. So then the second important innovation is the pendulum support. Can you just excuse me? Can you move this one? Yeah. So what happens is in a conventional cooler, the mobile frame is supported by means of rollers and bearings. And instead, in IKN cooler, the mobile frame is supported by means of a pendulum system. So this pendulum system retains the sinking of mobile frame. It doesn't allow the mobile frame to sink, and thereby the gap management is maintained for a long period of time. So these are the two secrets of IKN success. Number one is the Konda effect, segregation and stratified clinker layer, and number two is the pendulum support system. So this creates a sharp temperature profile, and thereby the efficiency will be higher. And let's now dive into the case studies. So this is the Dalmiapuram cooler. Recently we have retrofitted, and previously there was a conventional cooler where you can see the cooler loss is about 176 kilocalories per kg, and after IKN the cooler loss is reduced to 135 kilocalories, and thereby savings of 41 kcal per kg. That translates into 6,168 tons of carbon credits. And similarly, power was reduced from 4.05 to 3.85, and thereby 71 tons of carbon savings. And the replacement of metallic parts, you mean the spare parts also, the steel also requires a lot of energy, right, to melt and recast it. So in the conventional cooler, in every year, they'll replace approximately about 10 tons metal parts, and whereas in IKN cooler, the replacement will be only about less than 1 ton per year. So that translates into 9 tons metal savings, that is 7 tons. And then the additional power generation from the hot air recirculation system for waste heat recovery is about 0.5 megawatt is increased, and that comes to about 771 tons. And the total carbon equivalent savings about 7,017 tons per year. And this is the happy team of Dalmia Cement. And let's see another story, the sustainability. So this cooler in Lafarge RS Mehta was modified about 20 years before. And before IKN, the cooler loss was 123 kcal. And after IKN, it was 86. Even when we tested after 20 years, the savings about 37 kilocalories per kg and yielding about 6,158 tons of carbon equivalent. And power has come down from 4.6 to 3.1 kilowatt hour per ton, savings about 1.5 kilowatt hour, and 587 tons of carbon equivalent savings. And the maintenance also reduced, and which has come to 7 tons. And if you see the total carbon equivalent per year savings about 6,752 tons per year, and if you calculate 20 years equivalent, is about 1,35,000 tons, a huge savings. The many equipment suppliers will have a problem that sustainability will not be there. In the first couple of years, the equipment works well, and then as it keeps moving, the efficiency keeps reducing it. But whereas in case of IKN, we are able to sustain for a very long period of time. And this is how the cooler parts will be replaced in a conventional cooler. Comes about 10 tons of material per cooler. And this is the replacement of parts in IKN cooler in 1 year. You can see the quantity is very less. So with 124 million tons of clinker cooled in India by IKN, and we are saving about 23.5 megawatt of power and 10,500 wagons of coal. So these savings contribute to the reduction of 3,75,835 tons of carbon per annum. So let's make a greener tomorrow and save for future generations. So the innovation and sustainability define the leader. Thank you so much. If you have any questions, I can ready to talk.
Thank you, Mr. Rasi Raju. And now I would request our chief guest, Honorable Minister Dr. Shoshi Paja, to kindly address the gathering.
Can we just bring this down, please? Not yet afternoon, so good morning. And thank you for this invitation, and thank you to Dr. Rajiv Singh ji, Director General of ICC, Indian Chamber of Commerce, for this, I think, a very important discussion that we have all begun here on the decarbonization of the cement sector. I was listening, I had the opportunity to listen to very few speakers because I know there's a huge list. But I truly appreciate Mr. Vedant Agarwal, Director, Purbanchal Cement Limited. You have spoken, Mr. Anil Banchhor, Managing Director and CEO of RDCC, Mr. Nilotpal Kaur, Managing Director of MBCC, Mr. Madhusudhan Rasiraju, Country Head of IKN. That was very pleasant. I mean, we came to know about the coolers. I mean, that is very important, I think, the clinker cooling systems that you have developed. So I'm sharing the stage with all of them, truly privileged. And I also see that we have addressed by very eloquent and very important people, because now the concept is that you have an officer who is called the Chief Sustainability and Innovation Officer. So sustainability in growth, that is really coming in a very big way. Mr. Manoj Rostagi from GSW Cement, Sanjay Bhallaji he's the CEO from MAPEI, Mr. Suresh Agastiji, who is representing ThyssenKrupp Industries India, Mr. Yashwant Misra ji, who will be representing Mangalam Cement. We have another Chief Sustainability Officer of the Mahindra Group, Mr. Anirban Ghosh. He will be speaking too. And in the last session, Mr. Shaunak Shah, partner with EY, Mr. Narayanan Narasimhan from Dalmia Cement Bharat Limited, Mr. Rajesh Kakkarji from Birla Corporation Limited. Shamiji is here. I picked on Shamiji from the Heritage Institute of Technology. So all of you will be speaking, and I think those are very important things that we are all going to talk about, a very important discussion. Meanwhile, also other captains from the industry and also respected delegates. I was, in fact, telling Rajiv Singh ji, I know him for long because ICC does a lot of social work too, and there were times and instances where we have collaborated together for various CSR programs. Who would know then that I would also be in the Department of Industry and Commerce? And now I am requesting all the industry captains from the industry that come with your CSR. I have another department too. So it's like that. But having said that, and having heard a few points which the speakers have spoken, this is a lot of research. A lot of I would say there's a lot of a technical kind of a session that we are embarking on. A lot of research and technicalities is going to be there in the discussions, because you are looking at low carbon footprint, you're looking at low carbon emissions, we are looking at every process of the production of cement, which entails energy emissions or production emissions. And so, but at the same time, he was mentioning, I think it was Mr. Nilotpal Kaur, when he mentioned, very true, that after water, I think the most consumed product globally is cement. So that's where we stand. I just was thinking that after hearing you all, that cement industry per se, of course, who doesn't need a cement industry? We all want manufacturing industries to be there in the state. We also are looking at a tremendous convergence then, as we were hearing, that in fact, even the transport department, the power department has to be on board when we discuss decarbonization, because that was a very exciting thing which RDCC mentioned about e-scooters or e-cars, which they are giving to the employees. This is very innovative, I thought. So there's a lot of room for innovation, because ultimately, now as I begin to read or say a few things which I was, which also has been mentioned, that of course cement industry has the potential to contribute to the economy. As I said, who wouldn't want? Which state wouldn't want? We all want them to be in our state. And of course, obviously urbanization and rapid industrialization, which is promoting this industry to play a very important role in building our economy and also the nation's economy. So along with steel, as we understand that cement in India is about 1/3 of the world average as per capita consumption. And cement and concrete, of course, are integral to us, as most consumed construction materials due to its affordability. Again, the affordability portion and the versatility of the product itself. So this is extremely relevant, I think, because this is one of the old industries, just like steel and cement are one of the old industries. And but then we can never do away with it. But steel and cement are also the most carbon dioxide emitting sectors in India, accounting for almost 1/3 of the world average. I mean, statistics are very important. You have been mentioning. Study estimates show that by 2050, steel and cement would see a 3 to 4-fold increase in demand, and also again alongside tripling the CO2 emissions. So you have the demand and you also have the challenge coming together. Obviously, because both are energy and emission intensive, which you have been mentioning. I think you have gone through this recent data, which just was released in 2022 November. It speaks about the CO2 emissions from cement manufacture between 1990 and 2021. And the data release shows that, of course, China is leading with that, with the highest emission content of about 853 million metric tons, and followed a little bit far behind, but next we are there. India is there at 149 million metric tons. Far ahead, I mean, we are far above Vietnam, Turkey, and United States, and that's why that model becomes very important about the avenue in New York, which he was mentioning. These follow much later, much down the line, but China with 853, and we are standing at 149. Rank-wise, we are second. So that's a huge, I think, emissions that we are talking about, and we are now looking at this because we have to actually reduce the emissions itself from the process, in addition to the combustion of fuels for heat and energy to operate the process, the auxiliary machinery, and the supply chain to and from the cement plant. Most of it is known to you. It troubles us because this is true, truly, and it is very easy to narrate the problem, but what do we kind of have with it? It is also heartening that we are talking at sustainable construction now. We are looking at low carbon solutions, which we were looking when you spoke, and I think the others will also be delving more in that. We are looking at solutions and also the power sources to target the process emissions resulting from the chemical conversion of the raw materials. You mentioned about, and I was speaking to, again, RDCC about the fly ash, which he suggested, and the slag as alternate materials. We're also looking at the energy emissions from the production, which relies heavily on fossil fuels. You've mentioned again, our speakers have mentioned about biomass. They're shifting to biomass, the waste, the green hydrogen, the solar energy powers, etc., etc. So, a lot of R&D, technology innovations, and of course, renewable energy, etc. Now, the companies, there is a role, I would say, of the government. How we in the government are aware of it, aware of the problem, we are aware, but how much are we aware of the alternate pathway? And how we would be taking steps, and how strict are we when it comes to giving compliance to the new industry which would be set up, or those which are existing? How strict are we when you go through the EIAs of the industry? How much are we looking at it from the low carbon footprint? How equipped are we? How much are we trained and sensitized? These are also challenging questions which I ask myself. So having said that, it is again your research which will, I think, propel us to think in that direction, because you are talking about carbon capture. I mean, I being a student of science, of course, with a medical background, but of course with all the biochemistry which I've left behind. So you are talking about carbon capture, carbon storage by different methods like post-combustion, pre-combustion, and oxy-fuel. This is remarkable, I would say, that CO2 could also be used to produce commercially marketable products, which is termed as carbon, the CCS, which we are talking about. So we are all talking about CCS and its utilization. And I was just going through a report of a very reputed cement company, and it goes without saying that I would not mention names, because everybody is very important to us, but I saw that they were maintaining a very recently submitted report. Obviously, I got it on the website of that particular company, which reports like sustainability reports like CO2 intensity, greenhouse gas emissions, renewable energy capacity, the recycling of waste products, the alternative fuel use, the water harvest action that they have taken, the recharging and the recycling that they have done, the clinker factor reductions, electrical consumptions, etc., etc. It was all there in black and white on the domain. So the importance of today's seminar is thus very truly important, because you will be discussing SCMs, You will be discussing mineral admixtures and the pozzolans, etc. It is again very heartening, as I said, that you I was also telling Dr. Rajiv Singh that I would actually want to go through all the deliberations of the speakers today, because and also I don't know, as a conclusion, if you can add a portion at what you would suggest to the government. You would have suggested that to the union government, or would you suggest that to the government of West Bengal, whichever level that you address, because we are all responsible, and having seen such huge discussions which are happening, even the recently concluded CO27, and even before that, the global climate discussions and the huge events that are taking place. I think we are all responsible from our side to contribute as much as possible, looking at the future and looking at our future generations. So thank you very much for this invitation, and thank you for truly taking up such a challenging topic. It's not a very easy topic to, it's just not only to speak, but to execute the same. And as I said, please escalate your concerns to us, and let's see what we can do about it. Thank you so much.
Honorable Minister, thank you so much for such an engaging and informative talk. And now may I request all the speakers in this session, if you have any suggestions, since we have the Honorable Minister with us, so you can just put forward.
Hello. All right. So thank you so much, ma'am, for being here for us today. Currently, we don't have cement manufacturing in Bengal. Like, my family business is mainly out of Bengal and across India. But I want to explore, how we can have a synchronization and bring at least a grinding unit. I know limestone is not available. It's kind of scarce in Bengal, but grinding units would be very beneficial mutually here, right? So I want to explore such opportunities where, power is also on my side. Power costs are very expensive. So where, captive power, but coal shortages again. So, where we can synchronize and work on something, well, be mutually. Yeah. So, basically work on something along those lines.
Yeah. Madam, actually what we wanted to suggest to the government is that, as far as the clinker coal is concerned, there is no proper measurement and protocol available. So maybe the agencies like energy consumption agencies, BE and all that, they should form a uniform protocol so that everybody in the industry will follow the same protocol. Otherwise, what happens now, the people who comes there and they also say that we are also better than others. So that is creating confusion to the customers. So they are not able to decide which way to go. And finally, what they decide is, they decide whichever is cheaper. So that protocol should be bring into the practice so that the industry will aware of it, and then the parties will take care of that one. Thank you.
What I understand is your customers are the captains in industry, and they know the entire process. So I really cannot understand as to why the level of understanding will be short of what you expect. But having said that, I had a question or a query, or that any investor or somebody who's dealing in the cement industry, what is the additional cost that you have to entail to actually handle this low carbon emission? How much do you think is adding to your cost of establishing or running the cement industry?
On the floor also, anybody would like to?
I can give you one example.
Yes, sir.
Just give the mic to him.
Talk of CCU.
You could also introduce, please introduce
Carbon capture, utilization and storage. So cost of cement production may be around 3,000 rupees per ton. And at present, the scale of industries or the technology available, the cost is 3,000 per ton. So these technologies which are being developed in West, they are so costly as far as CCUS is concerned. So for our country, what Mr. Madhusudan is saying, we can save energy, we can have an equipment which is more energy efficient. That will be the low hanging fruit. But the cost of carbon capturing and these technologies are very, very high. That's why we need our own protocols, our own systems in India to, reduce our carbon footprints. It's really going to be a costly affair to match the Western countries in reducing this carbon footprints. I am Rajesh Kakkad from Birla Corporation Limited.
Yes, good morning, ma'am. This is Manoj Rustagi from JSW. Yeah. So the one of the point, we discuss, I work with, I'm part of JSW, but I work with a lot of associations globally, GCCA, which is the main Global Cement and Concrete Association. So one of the things, which we have is the incentive or, the government taking initiative in the green procurement. Now, one of the example I think, which was there earlier, that, is still the specifications which are done for the infrastructure projects. They are with the OPC, which is the ordinary Portland cement, which is close to 900 kg of CO2 per ton of OPC. Whereas if it is blended cement, whether it is PSC or PPC or composite cement, which are as per the BIS, available in India, these standards, this is ranging 300 to 400 kg. So it's almost 50%. But most of the projects even today, because, historically they have been using OPC, there is a resistance to change, and in the tender documents, they specify only OPC. And that is where the major issue is coming, that even if the cement industry is producing, we have 3.6 million ton of the capacity in West Bengal, one of the largest grinding units in West Bengal. We produce only the blended cement, slag cement, low carbon cement products, which we have. But for the infrastructure projects and the government projects, still, some of these specifications are only for OPC, not for the low carbon products. So green procurement is something, which is happening globally. Government of Canada, in fact, they have made it mandatory for the government projects, to only procure low carbon products. So that's one suggestion, which I had. Yeah.
Sure, thank you. Yes, would you like to? Mr. Anil, would you like to make any suggestion? Mr. Kar.
Yeah, I have a point, as Mr. Sugi said. Any government project, because many government departments, they specify pure OPC should be used. That they should specify either OPC plus fly ash and GGBS should be used as a combination, or factory met PSC or PPC should be used, not pure OPC, right? This is one suggestion. This will bring down the carbon footprint. And also, state government can say any truck running on the biodiesel should be allowed to go in the no entry time, or any truck in the CNG, truck, like in Delhi. In the CNG trucks, if they go inside Delhi, there is no toll tax on that. Like similar kind of incentive, the lesser polluting vehicle, some incentive should be there, they should be allowed to, so that every consumer, every manufacturer should go towards that green fuel trucks. So this is one. Plus also government should promote the terminals for the fly ash and GGBS, because these two are very green products. The usage of GGBS and the fly ash, because West Bengal government has got a lot of power plants, right? Normal fly ash is there, but there are many companies who wants to process the fly ash, and good quality fly ash can be used in the concrete, which will reduce the cement consumption also to a big extent. So this will lead to not only the carbon emission, but also the sustainability part. Both these 2 points.
Mr. Kar?
Yeah. So, madam, from my view, again, if the government drives the specifications, which has been mentioned by Mr. Rastogi and echoed again by Mr. Panchod, I think that will be the first step, in terms of usage of blended cements, which today I think central government, state government, they do not want to change things which have continued for the last 30, 40 years. So that is one major step. The other one is, and having worked in the cement industry before 20 years back, would the government consider transportation subsidy for waste which is going to be used for fuel? Yeah. So anything which is 200 kilometers away, yeah, the transportation cost, like the gentleman mentioned, cost of cement manufacture plus cost of carbon capture, yeah, so X plus X, twice X. So if some government subsidy is provided to the cement manufacturers, yeah, for using that waste, it could be a municipal waste, it could be any solid waste, tires, etc. That would be a great step, I think, to actually do it in a stepwise. Our country is so vast that you actually cannot do it, all in one go. So step-by-step process. So these are the two things which come on the top of my mind. Yeah. Thank you.
I feel that you should explain to the government whatever is very lucrative to the government, okay? I mean, so the government shouldn't think that I'm having to spend a lot more money or something, or I'm losing a lot of revenue. So make it very pleasant for us also.
Absolutely.
No, I mean, then it's difficult otherwise to push anything.
Yeah, there is a benefit. In fact, there should be some discussion centered around that with the government, that if the government does this, then what is it that the government earns in terms of revenue, right? Because there is an end point and every stakeholder should benefit out of it. Thank you.
And now may I request Dr. Rajiv Singh to kindly deliver the vote of thanks.
So thank you. I think we had a great start, and you must have seen when Minister joined us, I think she has really added her own personal touch, and that is what really differentiates her. We have known you, madam, for your very pragmatic approach, and you must have seen Minister knows a lot already, but anything which she does not know, she is willing to know. And what you have also seen, that she is willing to engage. And she is willing to make the difference for the industry, for the state. So on behalf of all of us, I would like to thank you, madam. And can we have a round of applause for our Honorable Minister. As ICC, I would say we really understand that Bengal as a state is well poised, because if you look at last 10 years, I think the governance, the reforms, the developments have been really path-breaking. Bengal has been growing at, let's say, above the national GDP rate. And if you also look at in the entire East, I think Bengal means almost 1/3 of the combined eastern states' GDP. And with the location and the opportunities, I think that is, Bengal is really well placed. And with the announcement of a deep sea port, I think that also goes well for the cement industry and the large industries. So Bengal is looking at the investments with open arms, willing to support, and you have a minister who is approachable and who is willing to help. Second thing, what we have also understood is that Bengal already has a lot of materials which are there, fly ash and other materials. It's a question of identifying those, developing projects based on those, and that will lead to what Honorable Minister said, that it also has to mean revenue for the state. It has to be not just subsidies, but it also has to earn some revenue for the state, and that is how it grows. So I think that can also lead to the revenue and employment. That's another thing. Maybe a small study can really look at what is the potential of, with so many power plants, the fly ash and GGBS, and what would it mean in terms of revenue, employment, and growth of the state. And if you think ICC will be happy to work with your department on this. The third thing is what we have seen, how do you make the entire process green? And that is where the use of fuel, e-vehicles. So that is again one area you saw that some companies are already doing it in terms of offering the e-cars and the e-scooters, and also the trucks, which can be electric trucks. So there again, government has a role to play, and we heard some thoughts in terms of what government could do. I would like to thank all our esteemed experts for making this entire session meaningful and interesting for all. I'm sure there are plenty of takeaways. I would also like to mention that ICC will compile all the key points and will submit a report to you in terms of how state can engage, participate, support, and what are the areas where it also means value for the state. So with this, we would like to end here, and there is a small token, so we would like to present to our chief guest.
Surya Cement and Icon Engineering for supporting this initiative. And now may I request the speakers of this session, Mr. Manoj K. Rastagi from JSW Cement, Mr. Sanjay Bhalla from Mapai India, Mr. Suresh Agasti from Thyssen Group, Mr. Yashwant Mishra from Mangalam Cement, and Mr. Anirban Ghosh from Mahindra Group to kindly join us in the dais. Mr. Rastagi, Mr. Anirban Ghosh, Mr. Manoj Rastagi from JSW Cement will be anchoring the session. He is the session moderator. And now may I request him to kindly start the session.
Yeah, good afternoon, everybody. So we had a very engaging and some very good presentations which were made in the first half. So we continue the discussion on the decarbonization of the cement industry, and we'll look at some of the levers which are there, which are existing, some of the levers which are in the future going to be there to decarbonize the cement and the concrete manufacturing industry. So we have a panel of eminent persons here. Mr. Sanjay Bhalla, CEO Mapai India, Mr. Suresh Agasti from Thyssen Group, Mr. Yashwant Mishra from Mangalam, and Mr. Ghosh from the Chief Sustainability Officer from Mahindra Group. So to begin with, I think it's been spoken about in the morning that concrete as a material is the most used man-made material. Water is used more than concrete, but that's more like a natural resource. So in terms of whatever we manufacture, concrete is the most used material in the world. And the reason for that is, it is actually, I always say that it is a sustainable construction material. It's a sustainable building material. It is affordable. It's been there for thousands and thousands of years. So it's part of the life, which we live. And whatever we see, I mean, the residences, commercial spaces, infrastructure, all the construction, is done with the cement and concrete. And this material is going to remain. This is going to remain because of the properties, which are there with the cement and concrete, making it a resilient material to use. It is. We talk about these structures when we design these structures, a life of 50 years, but there has been discussions, happening that the concrete structures actually can be designed even much higher. They can be designed, up to the 100 years life, more resilient, and that is how, the efficiency is going to come and the conservation is going to come. At the same time, we have a challenge with the focus in India on infrastructure. India is a growing country, and with the infrastructure emphasis and the residence for everybody, the consumption is going to go up. So we produce roughly 350 million. We consume roughly 350 million ton of cement every year in India, which is the second highest in the world after China. But if we look at the per capita is still low. So this is going to increase multifold. In the next 10 years, definitely it's going to be double the amount, what we have today by the end of this decade, by 2030. And at the same time, there is, cement is also called the hard-to-abate sector. Now, this is a technical term, the abatement of carbon. And why it is hard to abate, it is important to understand. Because the manufacturing process of cement starts with limestone, which is calcium carbonate, CaCO3. And when we calcine the calcium carbonate and make the hydraulic compounds out of it, what we call clinker, we remove the CO2 from the calcium carbonate and the calcium oxide plus CO2. So that CO2 is the major chunk of the CO2, which goes into the atmosphere. The other CO2 in the manufacturing process is coming from the fossil fuels which are used for the calcination and also, for the reaction. So which is roughly 40%. So the 60% is the process emission because of the CO2 coming from the calcium carbonate. And 40%, roughly are the emissions which are related to the burning of the fossil fuel. The best way to look at the decarbonization, if we have to look at it, is to first is to reduce the consumption of the fossil fuel. So look for the alternative fuels which are there. And the alternative fuels could be biomass, could be tires, could be the municipality solid waste or the RDF out of the MSW. So there are options, which are available. Most of the cement companies in India, they use alternative fuel. I think the numbers are by different people, they quote different numbers, but my own assessment is up to 10% of the substitution with the alternative fuel is already done. And most of the companies have got a roadmap, to take it to 30%, in the next 5-6 years. So that's going to be major driver in terms of, reducing the carbon emission. The other is the alternative raw material. So alternative fuel and alternative raw material, that's what we call AFR. The alternative raw material is also to look at, the sources of the calcium oxide and some of the other materials. So we have done some experiments, with the steel slag, which has got calcium oxide. There are other initiatives and the experiments, which have been done by the other companies, using the lime sludge from the paper industry. So it is available in bits and pockets, but then again, a lot of work, and that's why the innovation and sustainability go hand in hand, where the effort has to be looked for, alternative materials to the limestone, some of the waste material, which are there, even today existing, which have got a high percentage of the calcium oxide, to use that. So that's another lever which is there. With these two, the alternative fuel and the alternative raw material, there is a potential, to bring down 40 to 50% of the CO2 in the clinker manufacturing itself. Now, that's on the clinker manufacturing part of it. So the other thing which is there is, and in the morning it has already been spoken, is the use of the supplementary cementitious material. Now, that supplementary cementitious material, so in India we have the fly ash which is coming from the thermal power plants, and we also have the blast furnace slag which is coming from the steel industries. So these two SCM put together, they reduce a chunk of the emission because the clinker consumption or the clinker factor is reduced in the concrete or in the cement. So in India, we have specifications which are there for PSC, for PPC, for composite cement, where both fly ash and slag can be used. There are other specifications which are existing in India, but one of the things, recently when I was researching, I came across supersulfated cement, which is a fantastic quality of the cement, and the BIS is existing, for the last 10, 15 years. But it is just that, the people have not started manufacturing that, so we are working on it. The other thing, which is, can we make cement, with zero clinker? So can we substitute full clinker and have cement, without clinker? So that's the geopolymer Mr. Nilotpal was talking about in the morning. We have done our lab trials, which are highly successful. We did some piloting also, within our one of the manufacturing units. So that is the future, which is going to be there, to use only the cementitious material and convert it, to the final cement which can be used without clinker. But again, the point is how much supplementary cementitious material we can get. The supply chain issues, which have to be sorted out. Whatever the quantities which are available, have to be used. So today we are not using, fully full fly ash or the full slag, into the cement. So that consumption has to go up. At the same time, we have to look for within the clinker, because the clinker is still going to be there, even if the percentage is less. Look for ways, the alternative fuel and the alternative raw material within the clinker manufacturing to reduce it. So that's on the scope 1 side of it, the carbon emission. The scope 2 is equally important, where the electricity, whatever we use. So we have put up solar power plants, within our plants. A lot of other cement companies are doing it. And also the waste heat recovery. So one of the things with the cement industry, and which is a fantastic thing, is to use the gases which are coming out of the process plant, both from the preheater and the cooler, to use it with the waste heat recovery. And 70%, up to 70% of the power requirement of the clinker can actually be met from the waste heat recovery. So that's the driver and the lever, for the scope 2. But at the same time, we also have the possibility for the scope 3, as it was discussed, having the trucks and the transit mixtures and the other vehicles, which are there, to reduce the CO2 emission in the scope 3. Having said that, the focus, for most of us, the cement players, is to reduce the scope 1, because that's 70 to 75% of the total emission. The scope 2 and scope 3 is only 25% roughly. Again, depending upon the products, which are getting manufactured. The future, these are the levers which are existing. Everybody is working on that. The good thing is, in India, and we feel very proud about it, is we are the most energy efficient cement manufacturing companies in India. So our thermal energy consumption, the electrical energy consumption is the lowest when we look at the specific consumptions, per ton of cement or per ton of cementitious material. So Europe, for clinker, on an average is maybe 850 kcal. We guys, there are plants, which are operating even at less than 700 kcal per kg. So having said that, I think it's not easy. It is challenging. A lot of initiative has to be taken, but the industry has taken a lot of initiatives, and industry is working on that. We need the support from the designers. We need the support from the builders. We need the support from the government in terms of the low carbon procurement. So as collaboration is going to be the key going forward. If the industry has to move, towards the low carbon, then it has to be done in collaboration with the other players which are involved, in the whole construction. So the CCUS, I think, one point which we were talking in the morning. This is something, it's in India, nobody is doing it, and I think, it is slightly far away. But for net zero, to get to zero carbon, I think, it has to be done. There is no choice. But this is something, which is going to be over a period of time, the costs are going to come down. It is expensive today, but it is expected that as the maturity gets into the industry or the technology, for the CCUS, the specific cost, from $40 to $50 per ton will come down, over a period of time. And 10 years down the line, this is going to be technical and commercially feasible solution to decarbonize. So that's from my side, my notes. And I would now hand it over, for the other panel members to share their thoughts. To begin with, Mr. Sanjay Bhalla, CEO MAPAI. Thank you.
Thank you, ICC. Thank you, guests, and thank you, eminent speakers on the dais. Before starting my 15 minutes presentation, in fact, morning session was really good, and as I come from Delhi, and from last 2 months, every year it's happening, like end of the year, we start talking about PMI, SPM, NGT, and all bans, all restrictions, everything starts coming into the picture. Carbon emissions, everything. And I think even at my home also, and even at the school level, everybody knows that what is the pollution level now in Delhi. Because North is facing a big problem. And it's good, like the way construction activities and the government is spending on the infrastructure, at least we are more worried about the future. And MAPAI, as a MAPAI, which is a construction chemical company, plays a very small important role in the construction activity as compared to the cement, which is one of the major factor in the construction. But still we contribute to 2 to 3% of the total construction cost as compared to the other ingredients like cement, steel and all that. But it's as a responsible technocrats and all, it's our duty to really see what best can be done for the environment and what best can be done for the future. So as a construction chemical, there are different product lines what we have. So all these are basically 80% of these product lines are cement based, and how to reduce not only the carbon emissions but also to reduce the VOC content. Sustainability and communication is the key role now for every company, and that is for the MAPAI also. Raw materials, I said that as cement is one of the raw materials which we generally procure from a lot of vendors across the globe. Then transformation of the raw materials into the finished products, application, usage, and then recycling. Even we are trying to work on the products which are basically we are able to reuse the waste of the concrete into the construction. Environmental product declaration is one of the key goals of the MAPAI India, where we are already spending a lot of money which is spent on the profits margins, R&Ds into the environmental, and we are converting them into the green phase across the globe. In fact, we are labeling our products, couple of products as zero products, where zero carbon emission is there. So, like if I talk about the one of the product line heritage structures, where we have stopped using cement, and we have replaced it with our total lime mortars, and thereby using it for the heritage structures. Now, what we breathe basically when we see our kids really going through a lot of phases inside this. Living comfort is one of the agenda, indoor air quality, and what are we breathing? We are basically breathing volatile chemicals which comes from furniture, construction materials, a lot of fibers, particles, human sources, toxins, nanosized pollution particles from the outdoors. Indoor environmental quality, which is conforming to AMI code. There are different standards worldwide. So these are the VOC content which we should really be able to restrict to the limited level so as to have a satisfactory future for the future generations. Now coming to the major part, which is construction. Now, as everybody worldwide is talking that India is the fastest growing economy, with government targeting 8 trillion growth in the next coming years. So construction will play a very major important role, and mainly into the infrastructure which the government is planning to have the highways across the, and fortunately our infrastructure minister, Mr. Nitin Gadkari, is working on a lot of alternative energy resources so as to decarbonize the things for the much better future. Carbon dioxide emissions are identified as the main cause of the global warming. Now, production of cement, as you know, is a large source of CO2 emissions. Most of these emissions are due to the clinker production, chemical transformations, and thermal combustions. 0.84 ton of CO2 are emitted into the atmosphere to produce 1 ton of clinker. As a key component of concrete, cement is therefore identified as a contributor to the climate change. Around 3 gigatons per year of carbon dioxide are emitted into the atmosphere. Concrete is the most second, as we have discussed in the first phase also, it is the second most consumed substance after the water. 14 gigatons per year of the concrete is being used. Though it has got a unique characteristics and we cannot avoid it, but at least we can improve upon it. Versatility, resilience, ease of production, low cost, durability. Despite the well-known environmental issues, cement and concrete will be the construction material to focus on CO2 emissions. Okay, everybody knows that India is one of the second most largest after the China, the cement manufacturer, and it plays a very important fundamental role in the development of the economies. Reduction of CO2 emissions will be the main driver of the cement sector in the future, in the next years and the next decades. Roadmaps to the decarbonizations, Paris Agreement 2015 were limited global warming to well below 2 degrees centigrade compared to the pre-industrial levels. Over the years, we have planned strategies, roadmaps have been developed to achieve carbon neutrally by around 2050. The levels identified by the cement manufacturers can be grouped as thermal energy efficiency, fuel switching, reduction of clinker to cement ratio, innovative technologies. The current global average thermal energy consumption is around 3.5 GJ per ton of clinker. With the best available technologies, thermal energy consumption could be reduced to about 3. This level is expected to contribute 3% of the carbon dioxide emission. It involves upgrading of the kilns and the various equipments. Huge capital investments are required, and we have to see how the government and how the things can be taken shape into the future. This level is now reduction of the clinker to cement ratio, which we have been talking a lot. The lever is expected to contribute 37% of the CO2 global emission reduction. It is really an effective solution, does not require investments, easy to implement, measurable. However, clinker substitution is the solution in the short term, but not on the long term. Now, as a cement additive manufacturer, we can reduce the clinkers to a certain extent and reduce the carbon emission. CO2 reduction will be the main driver of the cement sector strategies in the coming years. Among the possible levels, the replacement of the clinker is the solution that is easiest and most effective to implement in the short term. Performance of these cements, particularly in the concrete application, could be difficult. Cement additives will play a key role, and we have to keep on modifying the cement additives, which best clinkers, different categories of the clinkers can be helpful in reducing the carbon emissions. The government has to really come out with a different specification into the tenders, BIS, IS standards, water standards, so as to have really focus on the carbon emissions. New standards necessary are to define new types, classification of cement, new requirements, and new test methods. As a company, our strive is to reduce the environmental impact, reduce the energy consumption, reduce total consumption and the water discharges, reducing the pollution emissions, reducing the waste production, and reducing the use of raw material. 90% of the purchased goods are from the local suppliers. We spend almost 0.38 million, which is 5% of our profit turnover, into the R&D activities, so as to focus on the carbon emissions reduction into the various, and not only carbon emission reduction, but also on the VOC content reduction in the various of the products which we are manufacturing, conforming to Gen EMI code emission dam. This is R&D. These are the emission test chambers. And then we check the reduction after using the various raw materials from a certain factor, which is without the usage of the raw materials, with the usage of the carbon emission or the VOC less content, and where we can come to a certain level of the reduction. So these are the different European levels which we are catering to, which are European levels and the American levels. So we have to standardize our levels as per the local Indian parameters also, because the kind of construction we are looking at, so we have to really focus on this. So our strive to reduce is the environmental content. We have to fight against the climate change, sustainability of the building, green buildings, LEED standards, assessing the impact of the products, durability of the systems. So we believe that sustainability is not a destination, but it is a compass for devising and designing a solution that is increasingly innovative and attentive to the environment of the people. So with this, I conclude, because there are a lot of things we can discuss with the time constraint. Let's build a sustainable future together. Thank you.
Yep. Mr. Suresh Agasti. Request if you can just do it in 10 minutes. Yeah.
So, very good afternoon to all of you, and thanks to ICC, especially Mr. Singh, Mr. Nilanjan and Ms. Ankita and whole team, inviting Thyssen Group to present our perspective on this occasion. And my special thanks goes to the previous session as well, and especially Honorable Minister graced the occasion, and it was very engaging session. And thanks to Mr. Rustagi to set up the tone, because most of the thing he mentioned, I think most of the technology player like us, Thyssen Group, is also working on these solutions, how to basically decarbonize the cement sector, and which is very important for us. So I'll be focusing most on the technology side. Just to start, how we are placed globally, we are more than 200 years old conglomerate, and our BU Policius, which provides the cement technology, is almost 150-year-old. So we are there, and we continue to provide innovative technology across the value chain wherever we can actually add value in the cement industry. So looking at the numbers, you see the cement contribute to the 7% of the total carbon CO2 emission, and it is almost around 2.8 to 3 giga tons of CO2, and which is huge actually. And this puts a lot of pressure on the entire global warming, the control which we want to put. And this has been also one of the talking point in the COP27 recently held in Egypt. So how to basically, if you see on the other side in the India story, see there are a lot of growth drivers. You can see in the slide here how India has planned in big way in the infrastructure segment, be it in the PM Awas Yojana or National Infrastructure Pipeline or maybe PM Gati Shakti, huge demand drivers. So how to basically at the same time grow and also contain the emission, that is the biggest challenge for us. And this is a catch-20 situation where, how to basically balance the both the situation while growing, also controlling the emission. That is where the technology player like us, we come into supporting the whole industry and bringing our R&D and other new technological advancement solution to the industry. And if you see, as Mr. Rostagi already mentioned, that the per capita cement consumption in India is quite low. If we want to really grow in the GDP 7% or higher, we definitely there will be a huge consumption of cement in India. So if you see ThyssenKrupp globally, we are also in the climate neutral path. We want to also achieve net zero. We are into many green technology. You can see into hydrogen, carbon to chemical in the steel sector, be it in the reduction of various emissions in the our industrial sector like chemical, fertilizer and other area. We are developing clean fuel with many partners, and also we are into supporting renewable energy like wind. So this is somewhere actually ThyssenKrupp is always there and it will continue to be there. And coming to the cement industry, the today's topic basically how to abate the opportunity in reducing, moving towards a low carbon economy. So that is where the main challenge to us, to the whole world. So as we already discussed, the panelists have already discussed that where we can actually add value. It may be in the where we are actually CO2 is being produced in the cement industry, and where we can actually reduce, got the opportunity to reduce, like in the fuel or in the raw material or in energy efficiency. These are the three areas, or maybe there are many other new things are coming like carbon capture and other. So these are the areas where we can actually add value in the technology sector, so that we can bring more energy efficient solution, or maybe in the use of alternative raw materials. Recently, this COP27 held in Egypt, you can see there is a fast mover coalition led by Mr. John Kerry, former US Secretary of State. You can see the leading cement manufacturer, and they have taken a pledge to basically reduce the per ton kg of CO2 emission drastically. You can see that I was listening to other panelists. In India is around 1,000. Somebody says that 1,000 kg. Which is huge actually. If you see on the slide, the most of the leading players are already half of that, and they still want to reduce further. So this is one of the challenging situation for us. We want to grow, and also we want to keep the emission low. So that is where we need to play the balance in the technology and in the value chain to control these emissions. And I think this is already in the talk of the town, like how to use alternate fuel, and so that we can actually reduce the carbon emission. This is where the challenge lies, how to basically utilize this waste material into our, put into the kiln and reduce the carbon emission. So like Mr. Rostagi also mentioned that many of the Indian cement manufacturers have already gone up to 10% of thermal substitution, and maybe there is a bigger target to achieve 30% in near term, 5 to 6 years. So that will be really a great story, to balance out the carbon emission for India. If you see how ThyssenKrupp initiatives actually transformative journey to key challenges facing the cement industry, we are basically what we are saying, we can add value. We can up to 100% alternative fuel can be used. That is where ThyssenKrupp is working on these technologies. We can also reduce 50% clinker factor by using alternative raw material. That is, these are the main levers which we can actually use in the cement production. And you can see many other technology we are working, like combustion technology, be it in the grinding technology, maybe burning or waste heat recovery, or many other areas like activated clay and NOx reduction. So one of the topic I just want to bring attention that, like we say that this AFR and substitution. Here we have already have some reference cases across globe, not in India, unfortunately, which we would like to have. More than around 9 installed projects already in place, you can see, and also that is equivalent to 550 megawatt thermal, and remaining 8 under construction, and many other projects are also in pipeline globally. So this is where I think the challenge lies for us. I'll just quickly move because I'm running out of time. So this is the technology we have, the pre-pole SC, which can up to 100% we can actually use the alternate fuel. And ThyssenKrupp can add value to the, first in India the problem is always with the waste, how to handle the waste. It is the supply chain of waste is really not in control. So that is where beyond the value chain that ThyssenKrupp add all these technology side. And also we are into waste heat recovery. Everybody knows that ThyssenKrupp provides waste heat recovery boilers and the entire power plant. And on the clinker factor reduction, there are many areas which I have already discussed. And the another thing I just want to introduce how we can utilize the fourth industrial revolution on digitalization, Industry 4.0. So here we can bring concept of Pollucious, our digital platform. There we have data management, predictive maintenance, performance optimization, and predictive operations. So this is another way to increase our efficiency in operation. And this is the Pollucious R Connect platform, where we can actually do all these, asset management and operations performance parameter monitoring. And and ThyssenKrupp Industries India, since last 75 years, we are helping our customers, and we are building many cement plants, integrated cement plants, and we can be one of the best partner to develop with for the future cement industry. Thank you very much, and if any questions, we'll take it later.
Thank you.
Thank you.
Just to put the numbers in perspective, the India average is much lower than the global average. The global average is 600 kg. India average is less than 550 kg. These are the data which is published, globally. So we are 10% lower than the global average even today. Yeah.
Thank you. Thank you very much.
Yeah. So may I request Mr. Yashwant Mishra, to share his views. Yeah.
Good afternoon to all and all the panelists. Thank you. Thanks to Indian Chamber of Commerce, especially in Eastern India. They took the initiative of starting this Cementing India. Last 3-4 years, I am also coming every year on their invitation, and again thanking them for this. I get some opportunity to address on some important issue before you. See, we are talking of decarbonization in cement industry. We have to understand what is cement. We produce cement, but whether the users also understand cement. They just know that we have to buy cement and make our house. But this is an binding material which will help us to make the building. In my opinion, what we have heard, history of cement is what? Major impact on progress of our civilization in the last decade, last century. What is this cement? It is a mineral binder which comes in contact with water and becomes like a stone. It guesses not only a stone-like. What it does, The properties allowed concrete to position as the man-made most widely used material in the world. And the demand is very huge. But during the process, especially pyroprocessing, it releases a lot of CO2 in the environment, which other panelists have also addressed. It harms all of us. How to mitigate all these things? Everybody is working, all the companies, cement manufacturers, government, general public contributes to all this. How the CO2 is coming from cement industry? First, through pyroprocessing, because it separates CaCO3 into CaO and CO2, because it has to go up to more than 800 degrees of centigrade to 1200 degrees of centigrade to make the clinker. And fossil fuel combustion for the kiln, which contributes around 35 to 40%, and the pyroprocessing around 65%, 60 to 65%. Now we come to the clinker is manufactured in the process, but it has given so much of emissions in the environment. How to reduce that? We have discussed so many substitutes, the clinker factor has to reduce. There are so many alternates we have developed in last 25-30 years. Fly ash from the power stations, which is available in abundance. Slag, blast furnace slag, which is the most commonly substitute used for cement. Especially in Eastern India, slag cement is widely used. Other parts of India, fly ash cement is mainly used. Still, if you go to any government tender all over India, you will find one specific thing: they need OPC cement. They don't need slag cement, they don't need fly ash based cement. So not only government, the general public also needs to be educated on all these. Why they need only OPC cement? And even the education is that level. Even most of us, if we have to build our houses, where we'll go? We'll go and say कि नहीं, छत के लिए तो OPC cement दे दो, और सब में PPC लग जाए, slag cement लग जाए, no issue. Because that education has not gone to that level. People are not aware still. After 50-60 years of such a big revolution in cement, nothing is of that time. People are still thinking we have to buy cement. And on the other part, people do not know also that what cement is coming, which cement is coming. The person who decides, the decision maker is that mason. जो राजमिस्त्री आके घर बनाता है, वो बोलता है कि ये सीमेंट ले लीजिए, ये अच्छा है. छत ढालना है तो यू टेक ओनली ओपीसी, डोंट गो फॉर पीपीसी, नो नो नो, डोंट गो फॉर स्लैग सीमेंट, छत गिर जाएगा. ऐसा नहीं है. Quality of cement is manufactured by the cement manufacturers, keeping all BIS standards and all other international standards also. So that creates a big hurdle in bringing down the emission level. Some data I will provide. We have seen that from 2003 to 2020, there is a fast improvement in the clinker substitution materials, and it has come up from 15% to 28% till 2020, and predicted to be around 33% in the long run. Cement is manufactured thousands of plants. Generally what is happening, fly ash is being used up to 35% in India. Slag is being used around 60-65% in India. But there are certain improvements which R&D has come. Now some companies are planning to introduce some cement, around maximum 10% clinker usage shall be there. We may see in next 1 year or 1.5 years those cements in the market. those are going to be helping the carbon emissions to be in the country. If we go for slag, in China, there are so many companies which have already started using around 60 to 70% cement, slag in all the materials, especially if we see the pavements in India also, in Calcutta also, anywhere, you see those fly ash bricks and fly ash pavements. There the use of cement is very less. It is around 10-15% maximum, not more than that. So those, in my opinion, the general public, the government and the companies, manufacturing company needs to address these things to common public, and they have to do on R&Ds that how to reduce those clinker substitute, clinker factor. And it is estimated that it can come down to less than 0.5 by 2050. People are discussing, but the other school is also saying the maximum 0.6 can be done. But yes, if 0.6 can be done, 0.5 can also be possible. Might be 5 more years or 10 more years. I would like to say clinker substitution involves, if finally we sum up, replacing a share of clinker content in cement with other materials. This could play a greater role than currently anticipated. Achieving an average global clinker ratio of 0.60% by 2050, as set out by the 2018 technology roadmap, has the potential to mitigate almost 0.2 gigatons of CO2 by 2050. The share of clinker needed can be reduced even further in individual applications also. And it can go up to 70 to 90%, as at some place it is already being seen. To be able to seek neutrality in the cement industry, the current method of cement production must change. There are many potential routes to lower CO2 emissions, and some are more prone to succeed than others. Nevertheless, the goal of CO2 neutrality in the cement industry can only be reached through an extended replacement of OPC by green alternative binders, as well through a transition from fossil fuel technology to a green-based technology. Thank you very much.
Thank you. Now may I request Mr. Anirban Ghosh, Chief Sustainability Officer, Mahindra Group, to share his thoughts.
Good afternoon, ladies and gentlemen, fellow panelists. Since morning, you've been listening to the experts. Now you have an alien who's not from the cement industry, and probably whose learning has mostly been from 3 organizations. One, JSW, Manoj and his colleagues. Another, Dalmia, I know we have a representative here, and the Ultratech Group. So if I say something wrong, you know who told me about it. I have a tenuous connection with the cement industry, and that is through our construction business in the Mahindra Group. Mahindra Life Spaces recently launched India's first net zero energy building. It has also said that it will launch many more net zero energy buildings, and I'm expecting that since it's a competitive atmosphere, many other builders will also launch net zero energy buildings. Question is, why are they limiting themselves to net zero energy? Why is it not net zero everything? Part of the answer is in what we are discussing today about the cement industry decarbonizing and hopefully moving towards net zero. Many speakers have spoken about the opportunity in the cement industry in India today. They are right, but I think they've understated the opportunity. It's huge. Depending on the report you read, 60 to 80% of the buildings required in India are not built yet. There is huge amount of infrastructure getting built, and we've only barely got started. Because for a country that is going to be 5 trillion, 10 trillion, you know, you've heard all the statements, the kind of infrastructure that is required is many times more than what we have today. In the near future, it is being said that more than half of all the world's cement will be consumed in India, just like we used to say this about China some years ago. That's the kind of opportunity we are looking at. So what's the role the cement industry will have? Will it end up building the world, or will it end up destroying the world? It's a question worth asking, because 40% of the world's emissions come from buildings. And a large part of that is embedded in the buildings themselves because of the materials that get consumed. So yes, this is not a very happy thought. But is this why you are going to go through your decarbonization process? Is this why the cement industry will decarbonize? Probably not. First, the cement industry will decarbonize because it can. And you've heard hundreds of ways in which decarbonization can be done in the cement industry since the morning, and I'm not going to repeat it for you. I hope you'll get copies of the presentation. They're very well done. Some of the tables and the lists are fantastic. If we do just that, we would have taken a very big step forward already. So there is a lot that can be done, and it will help the industry become way more competitive than it is now compared to the rest of the world. Despite the fact, as Manoj mentioned, many of our cement plants are among the most energy efficient in the world, energy being a very important cost in your business. So first reason why the cement industry will decarbonize, using all the tools that it is aware of now, is because it will add to competitiveness. But is this enough? The obvious answer is no. And the answer is no because other than reducing its own emissions, the cement industry also has a very big role in helping others reduce their emissions. How does that happen? I understand one of the methods of construction that's becoming very popular is My1. And buildings are using My1 technology, lots of concrete, not using bricks. Buildings are getting done faster, business is very happy, money is rolling in faster, working capital is lower. But the sustainability people are very angry because this technology leads to greater needs for energy for cooling or heating the spaces that get created. So one important thing about sustainability is not to look at things piecemeal, but to look at it in a more holistic manner to see, okay, so I've reduced my emission and I've gone and increased somebody else's emission by 2x, what is the net effect? So there will be new products required. Maybe My1 construction will happen, and maybe you will have a product which will create different thermal characteristics, which will allow My1 to become even more popular in a climate-friendly way. Let's take another example. And there was mention of air pollution in the internal spaces. Cement roads are fantastic, right? I mean, they last long, they don't have potholes, they're helping us grow our infrastructure. But the kind of road dust that gets created and the microplastics that come out of the tires and various other things that end up causing friction on the cement roads are something which we are not worried about today, but like thermal energy, like plastics, these are unintended consequences which we are building up for the future. A second thing that cement roads do is enable a lot of runoff of water. And you may have heard that water is a very critical thing, scarce, etc., big problem. The problem is not lack of precipitation. The problem today is the runoffs have increased so much that the percolation doesn't happen. And one of the major reasons is the extensive amount of concretization that's going on in the country. So what do? I understand that there is an innovation center in Bombay which has on display something called porous concrete. Now that sounds like a contradiction in terms, but maybe in future we'll have a product which will not only serve the purpose or solve the problems that concrete solves, but will also reduce the runoffs that are possible in the future. what will happen if you reduce runoffs? You'll actually reduce energy requirements required for pumping water to a great extent. Now, this is not something that the cement industry will automatically think of. But like I said, there are more ways to skinning the decarbonization cat than what we usually think of. There is, I know, a very interesting innovation project going on. I know JSW is a part of it, working with an organization called Zinteo, which is supposed to enable holistic thinking. And I'm hoping there'll be more projects like this, which will enable holistic thinking and will enable you to bring about decarbonization, not only within your factories, but also in the ecosystem at large. The last, or one more reason why what is happening now is not enough is because all of us have to become net zero together. So even as you're becoming net zero within the plants, if you're helping other industries who are using your products to become net zero, then we've taken a very big step forward. To do all this, obviously you need a huge amount of innovation. So along with competitiveness, decarbonization gives the industry an opportunity to innovate at scale if it looks at solutions holistically. The third reason why you will decarbonize is because you will be forced to. All of us will be forced to decarbonize in all our industries because the pace of decarbonization is too slow to solve the climate problem. There are solutions available already, but they are not necessarily being adopted at scale. You've heard so many solutions for the cement industry in the morning. Is there 100% implementation or even 50% implementation of those solutions in our businesses? Obvious answer is no. And this is why the pace at which we are tackling climate change is very slow. After some time, the problems will be so large. The storms and the glacier melts and the flooding and everything else will all become so large, and of course the heat strokes and so on will become so large that we will have no choice but to legislate implementation of at least the economically feasible solutions, of which there are plenty. Then of course we may be forced to legislate accelerated development of solutions which are not economically feasible today, but we know can become economically feasible if we do the right things. So here's a combination of reasons why you will end up decarbonizing. 1, competitiveness, 2, innovation, and 3rd, greater compliance, which is what will lead to greater resilience for all your businesses, and that's what we're always trying to achieve, to ensure that we make money in the short run and we are around for the long run. That really is the sustainability game. So what will you ask for the government? You've already done it since the morning, and you asked the right things: green procurement and to drive standards. But you saw from the minister's response that you're not about to get it very easily. So maybe the question should be, what should we do to ensure that we get green procurement and we get the right standards so that all of us as an industry can work together and make this happen? Can I help you? I actually have a new role. I'm moving on from being the Chief Sustainability Officer of the Mahindra Group to set up a Center for Sustainability at the Mahindra University. And some of the things we want to do is make sure that the kids who come out of there, at least the ones from, say, civil engineering or the various other departments, are ready to go and implement decarbonization solutions in the industries they go to. But we want to make sure that they learn the right things, because we've always complained of bookish knowledge, and that's not what we want to do. And that's where the university is actually reaching out to people like you to co-create the curriculum so that when the kids come out, they can help you achieve the decarbonization goals that you are setting for yourself. I hope we can work together to make this happen and solve the problems that we're all trying to solve. Thank you very much.
Thank you, Mr. Ghosh. I think in summary, I would say that there are ways and means, in which the decarbonization in the cement industry is possible. Maybe we are not ready to reach the net zero in the immediate future, but definitely most of the cement companies have taken target to go to net zero by 2050. Though the target which is given by the Honorable Prime Minister for India is 2070, as cement industry we are sticking to 2050. And in the long run, I think the possibility exists. We have seen from these speakers, there are solutions, which exist. It is just that the collaboration is going to be needed. The one of the things for the climate change, I think, is the acceptance that this is a problem. Once we accept this is a problem, I think the humans, it is there in the DNA, to look for innovative solutions and work around the problems. The way we tackled, recently COVID. So climate change is something, which is at a bigger scale, something where the pain which we are feeling right now is not that much, though we still have, the weather patterns, which are changing globally. But the intensity of those changes is going to increase in the near future, as Mr. Ghosh said. And that is where, the people are going to be forced to. And, but being humans, I think, we learn, we evolve, and we improve, and then we implement. So that's what, that's how, we really exist and prosper. So with that note, thank you very much, all the panel members, and thank you, ICC. We don't have time for the question and answers, but what I request you, if anybody has questions, please give it to ICC, and they will forward it to the concerned panel member, and then, we'll try to communicate on mail or messaging or whatever. Thank you very much. Thank you.
Well, thank you to all the speakers. I would request Mr. Nilanjan Chaudhary to felicitate all the speakers. Well, we are going to start the last session, Reduction of Embodied Carbon in Built Environment. I would request Mr. Shaunak Shaha, Partner Climate Change and Sustainability Services, ENY, Mr. Narayanan Narasimhan, from Regional Quality Head, Dalmia Cement Bharat Limited, Mr. Rajesh Kakkar, President O&M, Birla Corporation Limited, and Mr. Swami Vedajananda, Professor and PhD English from Department of Chemical Engineering Heritage of Institute. We would like to welcome on the stage. Well, I would request Mr. Shaunak Shaha, the Partner Climate Change and Sustainability Services, ENY, to start the session, and he would be moderating the session as well.
Good afternoon. Good afternoon, everyone. Let me first thank the Indian Chamber of Commerce for organizing this event on cementing India. I would also like to thank all the speakers of the previous sessions for bringing out a lot of meaningful insights, and I'm also looking forward to interact with all my co-panelists for their insights on reducing the embodied footprint in a built environment. I think this is very, very relevant as we have recently concluded the COP27, and we have seen there have been many deliberations on overall decarbonizations on global carbon emissions, and of course there have been a lot of debates, lot of confusions, and over the last 2 to 3 decades, we have been deliberating a lot on common but differentiated responsibilities. But having said that, I guess globally we all agree that there is no choice for us to make today, and we all have to collectively agree on certain common agenda towards decarbonization. From an India standpoint also, this is very, very relevant today, as Government of India has already taken a pledge and commitment to become a net zero economy by 2070. Now, if I look at India's total emission currently stands out to be about 2.7 billion tons of CO2, which is about 7% of global emissions. And there are a few macroeconomic trends or factors which I would like to just highlight. For example, the projected high growth rate of our GDP in the next few years, or let's say the change of livelihood patterns, or a very high increasing trend of urbanization, the high income level, disposable income level for the middle income community, which eventually would lead to a lot of changes in our consumption pattern. And finally, the usage of smart devices, which eventually would lead to a further increase in our carbon emissions. Now, having said this, government has already taken a pledge to be decarbonized and become a carbon neutral or net zero economy by 2070, which eventually means like most of the major economic sectors in our country would also need to focus on decarbonization agenda and take bold commitments towards net zero. Now, if we analyze the current national emission profile, we see about 20% of this emission is coming from the infrastructure, construction and building sectors. And this emission is also going to increase with the increase of our GDP growth rate, or let's say urbanization trend that we have been experiencing. And there are two major materials, one is cement, one is steel, which is majorly contributing to these emissions in the infrastructure space. Now, there are two main categories of emission in infrastructure segment. One is the embodied footprint in the built environment, which necessarily constitutes the upstream emissions associated with extraction or mining, manufacturing, processing, or even logistics of, let's say, the construction material, be it steel or be it cement. It also includes, let's say, the emissions that comes out as a demolition of the construction waste at the end of lifespan of any particular infrastructure. And the second category of emission is the emission which happens from the operational phase of any infrastructure. For example, the energy that we consume to have lighting, heating, cooling in any particular building structure. Now, if we look at the nature of the embodied footprint in any built environment, as I mentioned, this is happening mostly at the extraction or manufacturing processing phase. So this is more of a one-time emission. This is very, very difficult to manage because it is related to production of the construction materials, and this is irreversible in nature. So if we do not address the problem of, let's say, embodied footprint at, let's say, the manufacturing stage of the construction materials, or let's say even at the construction of infrastructure phase, probably that embodied footprint will continue to be there within the life cycle emission of our infrastructure. Now, cement and steel being the two major construction elements, and both of them are from two hard-to-abate sectors. Therefore, for Government of India, the country to become a net zero economy, it becomes very, very important that we also have cement and steel companies committing to the net zero agenda of the government. And thankfully, today most of the cement companies and steel companies in India have already started taking a lot of initiatives. We have got many cement companies, for example, Ultratech Cement, ACC Limited, Ambuja Cement, Dalmia Bharat, JK Cement, Shree Cement, all of them taking very active commitment towards net zero. And even the steel companies like Tata Steel, JSW, all have been started taking commitment towards net zero. Now, if we look at cement as a sector, while it is hard to decarbonate, and we see the maximum, someone was mentioning 60% of the emission of cement comes from the calcination of limestone while producing the clinker. And this is something which is irreversible. This is something which probably unavoidable if we have to keep producing cement with clinkers. Therefore, the only option that we have is probably reducing the clinker percentage in our cement, which means, in other words, to use more of blended cement. And there are a lot of requirements to educate our people for enhancing the usage of blended cement. The second most important source of emission in cement manufacturing is from coal, which is used for the thermal energy applications in kiln. And in this particular segment, I think the Indian cement companies have already made phenomenal progress in terms of substituting coal with alternate fuels. We have started using biomass, RDFs, plastics, tires, everything that we can burn in the cement kiln to substitute coal to produce this thermal energy. Future generation fuels like hydrogen, green hydrogen may also be looked at to substitute coal in cement manufacturing. And also keen electrification. I think this is still a very nascent stage, and probably Ultratech is one company which is trying to do some sort of a piloting on keen electrification, and this is also going to reduce the emissions from coal usage, provided we start getting electricity from renewable sources. Other initiatives like energy efficiency, renewable energy, or waste heat recovery is anyway something which the cement manufacturing companies are looking at today. Logistics emissions is again very, very significant in case of cement, and therefore we might need to look at alternate mode of transport, for example, railways, or even electric commercial vehicles. So someone in the previous session was also talking about electric vehicles. So how we can use electric commercial vehicles, a feasible option for cement transportation is something which we might need to look at. Long-term solutions like carbon capture, utilization and storage is again going to be looked at, but provided they become commercially viable, and which will take some time to happen. And carbon credits and carbon offsets, again to limited extent, can be looked at to neutralize any sort of residual emissions, because that's something which is not very well recognized as per the science-based target approach or net zero standard. Now, all these initiatives would eventually require a lot of capital investment. And cement being a highly commoditized item, which is sold, let's say, at a retail price of 8 to 9 rupees per kg, unless until we have a direct or indirect policy reforms or any kind of fiscal instrument to initiate this push, it would become slightly difficult for the cement companies to make a commitment towards such large-scale investment. And there we see the role of government reforms, policy reforms, regulatory changes, or let's say green financing mechanism, and to some extent even the need for green procurement and sustainable procurement policies, which would create this push to kind of for the cement companies to commit to this kind of investment. The other big area that we need to look at is innovation, both at a process level as well as a product level. And there I see the role of academic institutions to collaborate with the industry, with the government, to come out with circular economic business models, or to come out with alternate greener construction materials which will overall reduce the net footprint of the cement sectors. So today we have with us a few speakers from the industry. We have got Mr. Narasimhan from Dalmia Cement Bharat and Mr. Rajesh Kakkar from Birla Corporation Limited. And I would request them to share their insights, how they have been practicing sustainability and carbon management within their respective organizations. And we also have Professor Swami Vidajananda from Heritage Institute of Technology, and I would request his insights to talk more about what is the role of academic institutions, what kind of collaborations are they looking at towards decarbonizing the country and the cement sector as a whole. So I would now request Mr. Narasimhan to share his point of view.
Good afternoon to everybody. Thank you, Mr. Saga, for wonderful things about the decarbonization of the cement industry. Basically, cement industry is the one industry actually generating more of CO2 to the atmosphere, this one. So all previous speaker also mentioned that 1 ton of cement is required, that it will emit almost 0.84 or 85 tons of CO2 to the atmosphere. And out of this one, 60% is from the fossil fuel, this one. So being the cement industry, actually I am basically from the cement industry, particularly from the quality side. A lot of challenges is there to actually, when we have started using all this decarbonization, this one. In terms of quality of this one, we need to use a lot of good quality raw material, good quality fuel, fossil fuel, and good quality innovation technology. Everything we need to use it. Otherwise, actually, what will happen is basically this, whatever the product we are producing, it may not help into the society, this one. Apart from the cement industry, other area is basically that the environment, how this construction environment is actually generating CO2, and what are the ways actually we need to reduce that the CO2 emission from the, particularly when you are doing the construction. So that's more important, basically, very, very important, like cement and steel industry, how they are generating the CO2 to the atmosphere. This construction industry is also basically, we need to focus more on a lot of research and a lot of innovative technology, a lot of the things has to be there, so that this, at least we can reduce the carbon emission from when we are doing the construction. So basically my thought is that actually I just collected some information and just I want to share about this one. And it needs the government support, it needs the academic institution, research and development activities. Not only this one, even the construction industry also has to do a lot of R&D, new innovative technology, how to use the blended cement, how to use the reusing of material. Any newer technology of construction can be possible, so that the overall this country CO2 emission can be possible, this one. So my topic is basically the embedded carbon reduction in the built environment. That means the construction side, how we can reduce the carbon emission, this one. So before going to this one, and this is the plant actually, or Dalmia Cement plant actually, is one of the best plant in the world, and we are almost, later I will explain to you that what are the steps we are taking particularly for this plant and how we are reaching so much of the TSR percentage and all, what are the steps we are taking this one. And this is one of the greenest plant in the eastern part of the India or even in the world also, this one. And it's a digital innovative technology we are adopting. And people happiness and also the high performance of the plant is also one of the things. And strategic sourcing of raw material. And we have a limestone resource of 50 years and expanding the volumes and make it as a brown and green. Recently we acquired the JK Cement also. This one we are expanding our footprint in all other parts of the India also, this one. Coming back to this one, morning Mr. Nilotpal also talked about that some important steps about how the embedded carbon in the environment while doing the construction is possible. So these are the 10 steps actually we can think of this one. One is basically the reusing of the buildings instead of the constructing the new one, and specifying the low carbon concrete mix, this one. And can we use the blended cement, this one. Don't use UPC and use only blended cement. Government has to support also, and the mindset of the people also has to be changed and to use, not to use the OPC and to use the blended cement. And limiting the carbon intensive material and choose the lower carbon alternatives. Think about a possible alternative. Can we produce a wood structure instead of this one concrete structure? And the wood structure also withstand for longer time. And steel and concrete, this one. And lastly, this carbon sequencing material. Can we think of using agricultural products for instead of this one jointly with the concrete, so that it will be a win-win situation for reducing the carbon emission? Then maximum is the reuse of material. Reuse of material is also a very, very important this one. And can we think of the demolished concrete material, bricks and other things through making the new buildings, so that we will try to avoid the use of the, cement content in the concrete while constructing this one is very less, this one. Very recycled material, use of fly ash and this one, and maximizing structural efficiency, and finally that fewer finished material and also minimizing the waste. These are the 10 steps actually that the embedded carbon can be reduced. And this needs a lot of energy, lot of patience, lot of innovation, lot of R&D activities, lot of government support, and also lot of this one also in-depth innovation, technology, everything, and the construction company has to adopt this one. And with this one, definitely I am sure that going forward, this one definitely this use of this all these 10 ways will definitely reduce the construction industry carbon reduction, this one. And we are discussing basically about that built environment. What is this exactly? What is basically? It is a man-made surroundings that provide the setting of a human activity ranging from the buildings and the infrastructure to the parks to the open spaces. This is a simple definition for the built environment, this one. It also includes the physical elements of our surrounding that are constructed but modified by the humans, such as buildings and roads and bridges, this one. This built environment plays a critical role, particularly for the human civilization. It provides the setting for the people for a better life and better work environment, and also better interaction with other people, this one. It also influences the way people move around and access the various resources such as this one, and interact with each other's surroundings and their surroundings. other part is basically the green environment, that is the greenhouse gas emission. This built environment is one of the things which actually generating the carbon emission, this one. This embedded carbon is the just one of them, this one. It is only part only. A lot of other factors also is there. Then the transportation of this one also contributing the greenhouse gas emission. And also the waste generated by the built environment also contributing the greenhouse gas emission. As per the World Green Building Council, embedded carbon is the built environment is responsible for 11% of its carbon greenhouse emission footprint, which comes from the only material and the construction. Material means it is the cement, construction means the building, new building we are constructing this one. So this is the, our role is basically to how to make it this 11% into 0%. So that's very, very important. So everybody morning talk about this one. I'm not repeating this one. So 1 ton of clinker is required 822, 890 carbon emission, and how this can reduce, and that the global degree of that temperature rise, which we want to reduce by 2 degrees this one. So these are the possible ways in basically cement industry is adopting this one, increasing use of the blended cement, supplementary cementitious material, solar energy for making the power and to run the cement plant, and also using the alternative fuel, and also the in and around the plant increasing the plantation, so that every cement plant, there is a rule is also is that any cement plant or any industry, the 35% should be the where greenery development should be made in the particular industry. So that should be the compulsory, that should be made as a compulsory, so that we will try to reduce the CO2 emission from the to the atmosphere. A lot of new technology has been developed. I'm just touching the two. One is that geopolymer cement. Morning somebody also talk about geopolymer cement. This is basically the cement without any clinker. So basically cement without any clinker, I mean already in Europe it has been commercialized, and it's not a long way for India to develop this one. And cement industry is also trying this. A lot of R&D is going this one. This is geopolymer cement. I mean it's a clinker-free cement. Produce the cement with the use of alternative cementitious material with the slag and fly ash. And third one is that can we produce a cement from the from sea? So that is called basically it's a magnesium oxide cement. Cement basically produces cement with the using the seawater, and also after some precipitation can we make the cement this one. These are another technologies worldwide it is going on this one. So these are the two areas we need to focus on. A lot of industry, a lot of academic institution has to participate in this one, so that in future we'll try to reduce the CO2 to the atmosphere. So coming to Dalmia cement, actually what we are taking steps is basically we are working on the energy efficiency for reducing the power, and thereby we reducing the CO2 emission and productivity improvement, use of renewable energy for waste heat recovery. Also we are this one, utilization of waste from other material and thermal power plants, and also transportation of electric vehicle, and carbon capture utilization, and sustainable biomass as a renewable fuel. We started using the biomass also as a renewable fuel. And if you see that one, this is basically our roadmap for up to this one 2028, this one 33. And why I want to present this particular thing is that we are actually one company, one of the company we are targeting in 2040 zero carbon emission. That means our target is basically to have a no carbon emission from cement plant by 2040. Already we are taking steps, and a lot of R&D other activities going on this one. This is our roadmap, this one. And in terms of fossil fuel, and we are by FY33, we want to achieve 75% TSR. That means that we want to avoid the using of the coal, and we want to use the maximum fossil fuel, so that carbon emission can be reduced. Because 60% of the energy is coming from the fuel for to the making 1 ton of clay air. So that we need to avoid it. This one that will reduce the overall CO2 emission to the atmosphere. So this is the carbon footprint of Dalmia cement. We are the only company in worldwide producing the lowest carbon emission this one. So currently we are at 360 kg per metric ton of cementitious product, and our target is by FY28, next 5 years, we want to achieve 238 actually. So that's a great thing we are doing this one. And in terms of TSR, we want to achieve around 75% TSR by 33. Another 10 years time, we want to achieve by 75% TSR in entire all the plants which we are having in India. One of the projects actually we have taken is that to reduce the carbon emission is the use of the this one, in particular in our Umrangso plant in Assam actually. Can we think of using the bamboo as alternative fuel for producing the, clinker, by reducing the coal consumption in this one? So what we have done is that basically this one, these are the steps we have taken this one by end of 2025. We will be start 100% use of that this one, particularly. We will not be using any coal for this particular plant, and we want to use the maximum this bamboo as a fuel for producing the ton of clinker, this one. So by developing the community mobilization and training to the villages to develop this one, bamboo for this one, and developing the nursery also, free distribution to the sampling, and go by, finally by end of 2025, this plant we are targeting to produce a fuel, clinker production without any fuel, this one, use of coal, this one. This is our target. And one good thing actually in terms of carbon built environment is particularly in the construction is that, so these are the basically it's a clever thing which we need to do this one. If you don't build nothing, then you will be saving the carbon reduction as 100%. Then if you build less, then you will be around 75%. If you build cleverly, then you will be having 50% carbon reduction. If we build efficiently, this one, you will be having this one. So these are the 4 levers in which you can reduce the carbon emission at a certain different level. And all these things actually we need to do right from the planning side and design side, as well as this one in operation and the maintenance side also, environmental side. So these are the actually very good thing, this one. And let us work together and let us put our entire effort, because other speakers also will be speaking about this one, and previous speaker also speak about a lot of energy and a lot of how waste we can reduce this one. It's all our responsibility to make this one as this one, so that overall the CO2 emission to the atmosphere, particularly in the construction side, as well as the cement industry and other processing industry, can be reduced by this one, so that the future generation will be very happy. Thank you. So this is the last slide I am showing. This is and apart from this one, this is conservation of water is also very, very important, which will be reducing this one, because cement plant requires the water for running the plant, and that needs come only by running the electric power, this one. So we want to save the water also, this one. So this is the one plant actually we have developed a pond across this one. This will be this one, and this is also saving for the environment. Thank you.
Thank you, Mr. Narasimha, for your insights, and your 10 points agenda is going to be really useful for the users. And I do agree with you that a lot of collaboration would be required for the decarbonization agenda for the cement sector to become a reality. So thank you for your insights. May I now request Mr. Rajesh Kakkar from Birla Corporation Limited.
Good afternoon. I am from Birla Corporation Limited. We are cement manufacturers. Today's topic of reduction in embodied carbon in built environment, this doesn't cover the cement industry. It is from cradle to grave. It covers everything which is to be. We are living in buildings, we are living in cities. It covers the whole gamut of the topic. Cement industry is one of them. So they say that 7% CO2 is let out by the cement industry. But if you consider the total embodied carbon in built environment, it's about 40%. And of that 40%, only transport sector is 30% or so, and industry is 30%. But total CO2 emitted for in-built environment is 40% of the CO2. Of that CO2, 60% is in the operational. Once the building comes in form and we use it for ACs or heating, that is 60%. but 40% of that is embodied carbon. And we have to think about what that embodied carbon is and how to reduce it. You have listened to all the papers and speakers, very ways to reduce it. But one point is important. You know, I recently attended one conference by National Council of Cement, Building and Materials, where government, senior policymakers were also there. So once we are thinking of reduction in embodied carbon, so we must know, say in this building, how much carbon dioxide was emitted when this building was made. If you are not measuring the things, then you are not managing or controlling. You cannot reduce if you do not know how much carbon dioxide was consumed or let out when this building was made. In cement, in transporting the cement, in using steel. You don't even know which type of cement was used in this building, whether it was OPC, PPC, which type of steel was used, whether it was reused steel or it was a virgin steel. So once our civil architects and builders decide on making the building, they must, from that point itself, in the design itself, note down that how much carbon dioxide is going to be emitted when this whole building will be made. Only the embodied carbon. Operational is different. That will come in the design and how to reduce that operational emission. So that is very important, where we should have a system, we should have a digitalized data collection, and that is, you can copy from West, but that will not help you here. We have to have for our city, say city in our Calcutta, our buildings, how much CO2 is going to be consumed when I am constructing this building of a hotel. So our software, our people, our architects must know when they are making their design that they are able to calculate this. So first, measurement is very important. That's what we should do it. Now, in this embodied carbon, various ways you have already listed, people have told you, I'm not going to repeat it. I am only saying one thing. Minister was also here. See, this topic is such a wide and new. We cannot go by piece and meals. So if you say that environment is to be controlled, you cannot just say that only, okay, in the city of the Calcutta, stop diesel cars or stop petrol cars. Then you cannot say cement industry at once, immediately you implement technology to capture the carbon, that no CO2 should go out and you should capture 100%. It will double the manufacturing cost and you will not be able to use the cement. So it involves environment angle, it involves economic angle, and it also involves social angle. You cannot just pass out laws and so that you can stop using petrol from today so that environment is clean. So it has social angle also. Alternative technologies have economic angle. So we must have a core group in the government, a policy framework where from environment angle, from social angle, from economic angle, a group is made and then we decide how to go about reduction of carbon embodied in as built in our inbuilt environment. So that is very important. The steps being taken by the cement industry, reusing, recirculation of heat, renewable energy, solar power, wind energy, all this will go. But for a complete city, I will give you an example. When we talk of durability, you say that cement has to be durable for 100 years. You have to deliberate upon it, whether it is right thing to do or not. Maybe after 50 years, there is a technology much economically better, environment friendly than cement. Then maybe we need a building which should last 30 years. So we need to deliberate that what should be our concept of making this our buildings, our cities. So this is a totally new field. So you have to challenge the old thoughts, and a paradigm shift has to be brought in our thinking in, taking this cost of net zero emission, net carbon zero. This you have to look into a new angle, with a new angle. How to reuse the buildings, or the buildings are there, how we can make use of that buildings with the less cost. Many things are there and which requires, innovation and out-of-box thinking. So I just wanted to point out two points. that one, we must measure when we design a building what amount of CO2 is going to go into it. Second is, it cannot be done by one set of people. Architects cannot do it. It requires whole set of skills from electrical person, from mechanical, from scientists. So the government has to make a core group, formulate framework, and decide, give some guidelines to the people so that they can calculate this carbon being embodied in this inbuilt environment. And second is to challenge this thought that whether building should be very much durable for 1,000 years, 100 years, what cost should go into it. So I think I had only these 2 points to say. Thank you very much.
Thank you, Mr. Kakkar. May I now request Swami Vedajananda ji to share his perspective.
Harihi Om Sahana Bhavatu Sahano Bhunaktu Sahaviryam Karavavahai Tejasvinavadhitamastu Ma Viddhishavahai. Om Shanti Shanti Shanti. I am happy to be the last speaker of this program. Naturally, I will not go in a formal way because I don't want to stand before all of us and lunch, okay? And already Mr. Shaunak has told that you should watch on your watch so that I should not watch you, okay? So, fifth, cementing India. The first point I should mention that probably ICC has made this caption because of the cement industries. And so many, almost all the, cement sector, all the industries, barring very few, they are representing here all the big people from MDs and CEOs. But my conception is cementing India, that cementing should be in the form of binding so that we can have a very good, sustainable, developed India. Okay? And unless we can do that, then we can have the symposium, we can have the programs, but there will be the you can say the individual efforts. So it cannot be a holistic effort. So these were the changes. I am not going to discuss all the points. I think you have got the presentation also. And naturally, the industry has come up to 4.0. The industry 1.0, 2.0, 3.0, and now 4.0. And naturally, there we are getting lot of benefits. We are getting lot of problems also and benefits also. And naturally, these are the 2 top 10 skills for these today's industry, including cement industry. That we have the cognitive flexibility, we have creativity. Earlier, many of such things were missing. That is, just I compared with 2020 and 2015. And naturally, if this carbon emission, or you can say the reduction of embodied, carbon built in environment, so these are the steps. So, encompassing all the aspects, all industrial aspects. So, renewable sources, that zero discharge effluents, clean and biodegradable products formation, reduce carbon footprint, combats climate change, and limit undesirable consumption. Here are so many water bottles are here. Let us take one sip from one and simply we can keep it here. If we go on like this, then the ultimate end or goal cannot be achieved. If you are to take one water bottle, you are to carry that bottle. You should not discard it. So these things were not there in 2006, but now we are having, and we see that madam so using mobile phone. So there are the other things also. That is, these are the benefits: hassle-free system, efficiency, target level increased. That 3D printing, I think one speaker has mentioned about this 3D printing. Then borderless engineering. I was asking the moderator, sir, what is your discipline? He says so and so. So now in IIT Bombay there is one subject that is borderless. Actually, I belong to chemical engineering. Borderless chemical engineering. So that is there. And amalgamation of all engineering, medical, and management science. And these are the problems also. First of all, green economy inadequate practice. I already mentioned that by giving the water bottle example. Short time syndrome. This I tell my students, that if any lecture or anything, just if it is more than 5 minutes, then people will have the problem. They will start searching WhatsApp. And other things you were this is there. And there are the two strategies I mentioned. One is for the hydrogen economy, and other is some short-term measure, that is greenhouse gas emission by short-term strategy. So that is also relevant for our cement industries. And this is the concept of circular economy. My friend Dr. Mohan in IICT, who is also in the Prime Minister's Secretariat, as a that scientist. So we have some sort of collaborative work in order to have this circular economy, so that we can have the restorative, regenerative design, replaces the end-of-life concept with restoration, shift towards the use of renewable energy, eliminates the use of toxic chemicals, aims for elimination of waste from many materials, products, and systems. And these are the message of Swami Vivekananda towards the development of new India. What is that? That is modern science and technology. Science means, Swamiji said science that time, it should be science and technology with Indian ideas, and that will evolve a new dimension in the society. And there should be support from industry houses. Actually, you see, from the mathematics concept, if you need to enclose something, you require, a triangle. Triangle is you can say the minimum area it required. Minimum area means circle is of course minimum, but it has no edges. So if it is a triangle, then the base is the industry. The base is the industry, and the other two, if it is an equilateral triangle, you can say, the other two sides, that is the academia and also people. The minister has said that now so many industrial experts are here, but I have interaction with the corporate social responsibility projects with the industries. So unless the people part we exclude, then we cannot enclose this area. That is the main idea. Then enlightened trusteeship, that means the organizations, the industries, so they will have, there are the models I think we can see in Tata and many other industry groups, that enlightened trusteeship, and then it should be nation-centric, values and ethos-based, innovation-driven, holistic science and technology with development of individual at its center hub we need today. So as a practice of this, what is expected as an outcome of this particular program, here is one national symposium by our ashram with Jadavpur University. I am also the president of Vivekananda Institute of Environment Management. So that will be on 16th and 17th January. There we expect industries, we expect from academic people, we expect the students. The students will have their innovative ideas, and already Reliance has responded. They said that they will support a little bit so that the innovative ideas can be translated into the actual work. So if there is any WhatsApp group or anything like that, or any mail, I can share the soft copies. I have 2-3 copies of this program, and it is there in the Jadavpur University website. So please try to come, please try to join. For 2 days conference with lunch, we made it only for 500 rupees, okay? Because the idea is that the people should come, people should deliberate their ideas. So I am very thankful to the organizers for giving me the opportunity of sharing my thoughts with this August gathering. Thank you very much.
Thank you, Swami Vedananda ji. Thank you for sharing the insights from an academic perspective. Now, just to quickly summarize before we break for lunch, I think a lot of insightful deliberations from all the speakers, and there are 3 key takeaways which I just noted down. One is, of course, the design state changes because the emission footprint in the built environment is something which is irreversible in nature. So if we do not look at the design state changes, then probably that one-time emission would be very, very significant. And Rajesh ji was mentioning about 40% of emissions come from the embodied emission footprint in built environment. The second is the need for country-specific or regional standards and guidelines. Rather than following maybe some of the Western standards or guidelines, if we also have country-specific and regional codes, guidelines, policies, which would be properly disseminated to all the users, so that we can also follow those kind of guidelines to come out with construction materials or construct a particular infrastructure in a most low carbon emittive manner. And third is, of course, the ecosystem change. It needs a lot of collaboration from government. It needs a lot of deliberations between different engineering disciplines, be it civil, mechanical, electrical, or even the architects, to come forward, collaborate, and then come out with something which is a more viable solution. And finally, I would like to take the note from Swamiji, what he also mentioned, that we individually cannot also disown our responsibilities, and we might need to revisit our own consumption behavior, our own consumption pattern, so that we also individually contribute to the larger decarbonization agenda of the country. With that, I thank all of you for attending these sessions and hand it off to Indian Chamber of Commerce. Thank you.
Well, thank you, Mr. Shaunak, for such a wonderful deliberation. I would request Mr. Nilanjan Chaudhary to felicitate the speakers. Well, thank you to all the delegates over here. Thank you to all the speakers. Thank you to our sponsors, the associate sponsor JSW, and the corporate contributor, ThyssenKrupp, IKN Engineering, RDC Concrete, Surya Cement, and MAPA India. So we are concluding the session today, and the lunch is open now. Thank you so much.